When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Waqf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Waqf can bless our community with a legacy of care.
Oh man, what a way to start a workshop. A warm welcome to all of our learners that are joining us online. Good morning to you. Goeiemorgen, Sawubona, Namaste, and Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to the Awqaf SA Grade 11 workshop. We are coming to you live from the Falaah College in KwaZulu Natal. Well, at least Mr. Khota is. I'm beaming to you live from the Awqaf SA Cape Town studios here, and it's a warm welcome to you. We are going to be focusing on grade 11, Maths Paper 2. Mr. Khota will be taking the learners through these sessions today. We had lots of fun doing Maths Paper 1. So we will link the link to that paper, Maths Paper 1, that we did yesterday, in the description. Kindly do note that these videos are hosted on Awqaf's YouTube platform. So do give our platform a like and subscribe to the platform. We will be hosting workshops in August and in October. So if you do subscribe, we do post regular information and info sessions on our platform. so you won't miss out on anything. My name is Hassanin Abdullah, and I'm from Awqaf, South Africa. We are a development organization. We are here to uplift communities through our sustainable projects. We do boreholes, we have interventions around health development, and this is our contribution towards providing quality education in South Africa. And we have been conducting these workshops for almost 9 years now. Next year, we will be commemorating 10 years of hosting this workshop. So I won't be doing much of the talking. This is just by way of introduction to this program. Hope you have fun. Please let us know in the comments where you are connecting to us from, which city and the school. Let's keep that conversation going, and we'll put that comment up later. So enough speaking from me. Let's call on Al Falaah College's principal, Mr. Zaf Ahmed. He's been very instrumental with this Awqaf SA Maths workshop since its inception, and would like to talk to him and also reflect on the volumes of learners that's been bussed into the venue to come and benefit from the session. So we'll call on Mr. Zafar Ahmed. Assalamu alaikum, Mr. Zafar Ahmed. Take the show away.
How are you doing in Cape Town?
We are well. We are doing well. The weather is fit, and I wish I was in Durban with you.
Excellent, excellent. Then we want to thank you, Hassanin, for managing the program at our studios in Cape Town and making sure that we have a smooth day like we did yesterday, bringing this program to the 300-400 students that are in Al Falaah Hall, as well as many hundreds and thousands others that are streaming in on the YouTube. It gives me great pleasure to again welcome you all in the name of peace and blessings. I want to commend the group that are in Al Falaah Hall. You were such a wonderful group. You were well disciplined. You participated well. I'd like you to give yourself a round of applause. And I hope you're going to have another fun-filled day, enjoyable day, and you're going to learn a lot. I just want to also just acknowledge Awqaf South Africa and Al Falaah College, who for many years have been hosting these maths workshops for grade 10, 11 and 12, and we do it 3 or 4 times in the year. And we're very honored that we've had such support from the Department of Education and many of the state schools who take the trouble to bus the children in, and it's our privilege to actually have you here as our guest at Falaah College and to afford us the opportunity to bring a master tutor like Mohammed Khota to inspire you and prepare you for your maths exam. Without taking up much of your time, I'd like to welcome you back to Falaah College, and I trust you're going to have another enjoyable, fun-filled, educational day. All the best. Take care. Thank you very much.
So there we go. That was Zafar Ahmed. Definitely himself and his team at Al Falaah College do deserve a pat on the back. Currently at Al Falaah, there's probably about 400 learners. That forms part of the in-person attendance. So let's call on Mr. Khota. Mr. Khota is a maths facilitator. He's been assisting us in our program. This is an intervention to prepare learners for the examination, and this is a preparation for the prelim examination. Just to remind you that we host these workshops in May, August, and in October. Please do subscribe to our YouTube platform. We would really like to reach 7,000 subscriptions before the end of the month. So we'll call on Mr. Khota. Mr. Khota, definitely as part of the secret to his success, he has a unique flavor of humor, and he makes learning maths quite fun. So let's get ready for the launch. Let's all get on board the Awqaf SA rocket, and we are going to go to higher ground. So let's cue the launch video for Mr. Khota.
Eight,
Mr. Khota,
Assalamu alaikum, assalamu
are
alaikum.
you ready for the launch?
Wow, we're ready to fire off we're firing on all cylinders. And a very warm welcome to South Africa and to our online cohort of learners as well as our on-siters. Now, I think before we get the program started, Hassan, what do you say we let our learners give a Mexican wave to get the party started?
3, 2, 2, 1.
Let's start
Mexican
the
wave.
this time.
Oh, we need another one.
They don't know how to do a Mexican wave. Hassan.
We need another one. Niman.
You have to stand up and right. 1, 3, 2, 1. We don't
One.
jump that way. There we
Go. Yeah.
That's right.
Woo.
There we go.
Yeah.
Well done. Give yourself a nice round of applause. Welcome. Jazakallah. Okay, guys. Assalamu alaikum. Warm welcome to you also. Jazakallah for everything. Yesterday has been an exceptional day. We had amazing feedback from all our cohort of learners from across the country, and I hope everybody is fired up for today's bumper session. Let's get started. What you're going to need for today, make sure you have your scientific calculators, your writing pad, your stationery, your snacks and your hydration. And I'm going to wrap up. You can connect, obviously, through Facebook, Instagram, X, YouTube, or on the website. Or you can go to the Awqaf SA on YouTube, go live, connect. Wherever you're connecting from, just learn. Remember, we are days away from your June exam. And hopefully this weekend here will help you to prep completely. Now, we got the program 9 a.m. to 10:30 analytics, but I wanted to finish off that functions component, hyperbola with shifting asymptotes and one exam model. So let's do that. Let's start with that, and we'll do analytics. 100% we'll finish off by 10:30. Our second session will start with trigonometry. That will take us through to lunch, and then we'll do our favorite section, the one that I think everybody's waiting for, Euclidean with the 11th theorem. So yeah, Hassan, let's get cracking. Let's get fired up.
Take it away.
Here we go. Okay, guys, Bismillah. Let's get started. Here goes. Right. We're starting with so put the heading there, the hyperbola with the shift in asymptotes. Hyperbola with the shift. That's where we're starting. 100% you're getting tested on this. You'll get tested on this now in June. You'll get tested in every functions paper. Like I said, we're finishing up. We're finishing up from yesterday. So you know that the standard formula y equals a over x. That's your normal hyperbola minus p plus q. So that is your shift in asymptotes. The p value is your x asymptote. But obviously when you're putting it in, you're going to change the sign because the negative changes the sign. So the p value is your x asymptote, but remember the negative changes the sign. I'll explain to you what this means when we start with it. The q value is your y value of your asymptote, and obviously you leave the sign. So in your formula, if this was x minus 3, then your x asymptote would be plus 3. X is equal to plus 3, because the minus changes the sign of this. Okay. So let's start off with 1. We're going to sketch. We're going to find, we need our y-intercept, we need intercepts with the axis. We need asymptotes. We need axis of symmetry. Very important. Right, so let's say they tell you to sketch the graph h of x is equal to 4 over x minus 1 plus 2. There we go. Let's sketch the graph. So the first thing that we need our equations of the asymptotes. Equations of asymptotes. Very important. That's the first thing you do. So we know x is equal to 1, not minus 1.
x is equal to 1. That's your first equation of your asymptote. And y is equal to 2. So that's your p value. P is equal to 1 and q is equal to 2. But these are the equations. The equation is in terms of x and y, not in terms of p and q. P and q is just a representation of what it means. How's our onliners doing there, Sanay? Good morning, good morning, good morning. Hello, High School Cape Town. Some shout-outs, yes. Some Kelo Sam. We've got Omofolo, paper 2, Siabonga, secondary, morning, Meadowlands Technical, Bulelwa, Komani, welcome, welcome, welcome everybody. Afrikaans World School, Sasolburg in the Free State. We've got all 9 provinces in the house. So there we go. Equations of your asymptotes. Now we need the intercepts with the axis. Intercepts with the axis. Where is your graph going to cut? So your intercepts with the axis, you're going to say let x equal to 0. So if x is equal to 0, y equals 4 over 0 minus 1 plus 2. Let x equal to 0. So y equals, that will give me minus 4 plus 2. So therefore y is equal to minus 2. So when x is equal to 0, y is minus 2. Please, this is a model. I'm not just doing random examples. This is a model. If you can do this one, you can do them all. Copy and paste. What's important is not the numbers for now. What's important is the system that you use, the process that you use. So the first thing we needed to do was get our equations of our asymptotes. X asymptote, y asymptote, intercepts with the axis, let x equal to 0, solve for y. What do you think is our next process? Let y equal to 0, well done. And I was so proud of you guys yesterday that you were pulling out my algebra errors through it. Honestly, it actually showed me that you guys were fully engaged. I thought towards the end of the day you guys would become a bit snoozy, you guys will log out, you'll disconnect. You guys were online right through until the end. So you guys were amazing, and I think you guys are going to be even more amazing today. Alright, so stay focused. Some mistakes I'll make unintentionally, some mistakes I'll make intentionally. So you need to stay focused. Alright. Let y equal to 0. So now we're going to go 4 over x minus 1 plus 2 is equal to 0. Now let's solve for x. I'm going to move over to the side. So 4 over x minus 1 is equal to the plus 2 will go on to the other side as minus 2 over 1. Cross multiply, minus 2 into x minus 1 is equal to 4. Remove the brackets, minus 2x plus 2 is equal to 4, minus 2x is equal to 4 minus 2 is 2, so x is equal to 2 over minus 2 is minus 1. That means minus 1 and 0. There we go, these are your intercepts with your axis. Those, when x was 0, y was minus 2. When y was 0, x was minus 1. So there we go, equations of asymptotes, intercepts with the axis. Sometimes, in most cases, if you guys have been, if you're familiar with working through past papers, please guys, past papers is key. Work from 2018. What year? What year? 2018. You take the June papers, national papers, you take the final exam papers from 2018 right up to 2023. You take all the papers, you download them from the NSC website. You can go, there's so many sites that have the past papers. Question paper memo. You make a file. You print them all out, ask your teacher, ask your school, whatever. Get them printed out, make a file. You have to work through past papers to learn the structure. You'll notice in the past papers, if you learn my methods, man, you're going to fly through those papers. And the more, now you must start timing yourself to see how fast you can finish the paper and get 90% for your paper. Remember, mathematics is about 3 things. Mathematics is about how many things? Sand. You know the sand and the koi koi. S-A-N. The Griquai and the Makwalanders and the Hareros. Ever heard of them? Those of you who do history. the indigenous people. Maths is about three things: S-A-N, the sand. S for speed, you work fast. A for algebra and accuracy. Make sure your algebra is sharp, make sure that you are accurate. So S-A and N, work neat. At least be able to read your own handwriting. If you can't read your own handwriting, how is your marker going to read your handwriting? Some of you write like you take a cockroach and you put it into ink and you let it run across your page. It looks like that. It's an eyesore. So speed, accuracy and algebra and neatness. Right, let's sketch this graph. Let's sketch this graph. So let's go. I'm moving over here. Onliners, are you guys with me? Hello, hello, hello. How are we doing? Umfundo High School, Cultura High School, Wentworth. Umfundo, well done. Pakamani, well done. Let's go. Right. So now let's sketch the graph. The first thing we do, we insert our asymptotes. So watch here. Here we go. What's our asymptotes? That's our x-axis, that's our y-axis. Your asymptotes, 0 and -2. So let's go to our graph. 0 on my x, -2 on my y. The other one was -1 and 0. Those are our two intercepts, our two asymptotes. What were our asymptotes? Let's go back. Where were our asymptotes? X was equal to 1, y was equal to 2. X is equal to 1, x is equal to 1, so make a dotted line going through 1. And y is equal to 2. There we go, those are your asymptotes. Your graph will never touch these two lines. Don't ever get confused between asymptote and axis of symmetry. You know asymptote, the abbreviation is the word S. Now you know in life you can't, if you want to know what's the difference, you know in life you can't go touching somebody's. So you know
Mr. Khota.
your graph never touches. So when you see asymptote, don't touch. Stay away. Stay away. Wrong. You will be fined. You will be jailed. So please, asymptote, don't touch. And don't go around telling people nice asymptote. So there we go, we joined those two dots and it was positive, so it's in your first and your third. So it's in your first and your third quadrant. So asymptote is your line which your graph never touches. Know that. So the equations of our asymptotes here is x equal 1 and y equal 2. Now they're going to ask you for the equations of the axis of symmetry. Now very easy, pay attention. The equation of the axis of symmetry you get with a positive gradient or you get with a negative gradient. Sometimes they will specify, give the one only with the positive gradient or give the one where m is less than 0, where your gradient is less than 0. So positive gradient, m greater than 0. Because you know, axis of symmetry is y equals mx plus c. Straight line. And this is for m less than 0. So very easy. Just go y equals x plus c or y equals minus x plus c. This is what a positive, this is for m greater than 0. M greater than 0. And this is for m less than 0. Now which point do I put? Remember I need to solve for c. Which point do I put for x and y, x and y? I put the point where the two asymptotes meet. Remember your one graph is going to go like that with a positive gradient. Your other one is going to go like that with a negative gradient. So it's going to go through this point, 1 and 2. So the point that we have to use is 1 and 2. You cannot use that, you cannot use that. You have to use where the two asymptotes meet. Are you guys listening to me? Right, now let's substitute. That's x, that's y. So 2 equals 1 plus c. So C equals to minus 1, C is equal to 1. Now your first equation, here's your first answer with a positive gradient, y equals x plus 1. On this side, 2 equals minus 1 plus c, 3 equals c. So y equals minus x plus 3. And that is your second equation of, this is for, with a positive gradient, and that is your equation of your axis of symmetry with a negative gradient. Please learn this. Learn this. I told you maths is easy, you must just know how. Know what to put where. What's the purpose of math? Math is there to simplify your life. So you need to know which tool to use. After you put it, then it's substitution. So know the tool, which tool to use, then you substitute. And after you substitute, you use algebra to simplify. This is math. The whole of mathematics. To simplify or to solve. The whole of mathematics is know which tool to use, substitute correctly using your brackets, and then use your algebra to simplify. If you can do that in anything in math, any topic in math, that's the purpose of math. Problem solving. So know the tool, substitute, use your algebra, get your answer. Simple as that. 3 steps always in math. Always. In every topic. So these are the equations of the axis of symmetry. What's the domain? What's the range? If they ask you what's the domain, what's the range? Right, what's your domain of this graph if they had to ask you? X is an element of real numbers, but x cannot equal to how much? 1. Good, because that's your asymptote. What's your range? Y is an element of real numbers, but y cannot equal to how much? 2. Finish. Was that difficult? No, this is baby work. This is baby work. Alright, come I show you. Come I give you a higher order question, right? Come I show you some tricks now. Now you want to, alright, but first let's find out the equation if the graph is given. We now learn how to sketch. What happens if the reverse is given? And then I'll give you 1 or 2 questions. Then I'll give you an exam model. We are combining everything. And then we're done with functions. Then we go into analytics. And analytics is easy. It's a walk in the park. Guaranteed 20 marks. You might get 2 questions. 20 marks, 20 marks. In your final exams this year, if you're writing a common paper, you'll get 2 questions in analytics. 20 is 40. 20 marks for data handling. That's 60. 40 marks for trigonometry. That's 100. 50 marks for Euclidean. It's 150. Right. So here goes. Now check this one out, guys. Check this one. Right, so let's give you a graph. Let's give you our graph. Onliners, how are we doing there? Give us a thumbs up if you're enjoying today's session. Here's an exam model. So now I'm giving you that. I'm giving you this. Take this one down quickly. I tell you that is -2. I tell you that part is -4. And I give you a graph going like that. And I can give you, this is graph H. But I can give you any point on this graph, whether I give you the intercepts or I give you any other point. Let's say I don't give you the intercept. Let's say I just give you a point here and I call that point T, 1 and 5. There we go. Question number, alright. The graph is given by h of x equals a over x minus b plus q. Show that a equals something, b equals something or Q equals something, or basically just find the equation of H. Find the equation of H. That's your x-axis, and that's your y-axis. Onliners, how are we doing? Hasanain, how's our onliners? Are they vibing with us? Are they grooving with us? I think thumbs are coming up. Loazi, Zodwa, Tando, welcome. Umlazi, yo, mashallah. Chuma, my choma. Arsenal Steel, welcome, brah. I will go 120%. That's it, Sipalele. 120%. Let's go. Hi, Grace. How are you doing? Kwama Kuta Comprehensive. Orient. Ghulam Abdul. Mashallah. Welcome. Right, let's go. The first thing we do. Y equals A over X minus P minus 2 minus 2 plus 2 minus 4. That's your P value, that's your Q value. If they had to ask you for the equations of the asymptotes, the equations of your asymptotes is what? X equal minus 2, Y equal minus 4. Not P and Q. Remember, x equal minus 2 is a straight line going through minus 2. Y equal minus 4 is a straight line going through minus 4. So whenever they ask you for equations, you give it in terms of x and y, not P and Q. Are you listening? Mamela. Open up your ears. Right. What are we looking for? A. We're always looking for A. You know, whenever you're given a graph, listen, whenever you all do English, you know, you do alliteration in English. You know what is alliteration? When they repeat the same alphabets. So if you want to remember what alphabet are you looking for always, just remember, in algebra, A, in any starts with A, function, the A always is to find A. In algebra, in any graph, the A, always A is to find A. Okay, you're always looking for A. A is not given. You have to find A. Right, so let's go. So that's X, that's Y. So let's go. 5 equals A over X is 1 plus 2 minus 4. Now 5 plus 4 is equal to A over 1 plus 2 is 3. 9 equals A over 3. A equal times 3, A is 27. So h of x is equal to 27 over x plus 2 minus 4. There's your answer. Final answer. Right, we good with that? Right. Let me give you 2 higher order questions with regard to this for matric also, for grade 11 and 12. So you must remember all what you are taking down now, these notes over this weekend, you look after it. You're going to need it for next year also. You'll refer to these notes and master the way I do it. If you keep on mastering our notes now, every time you come for a workshop, we all know we're going to be using the same way to write our final paper in matric, in grade 12. We're going to be using the same methods. I'm not going to change anything. The same method that we're going to use now, we use in matric. It's the same way it was used 1,000 years ago. Maths didn't change. Maths didn't change. Processes stay the same. Right, here goes. Watch this. Check this one out. Onliners, check this one out. Y equals x plus 4 and y equals minus x minus 6 are the two axes of symmetry. I've seen this in the paper. After hyperbola would shift in asymptotes, I've seen this question. I'm just changing the values. Y equals x plus 4 and y equals x minus 6 are the two axes of symmetry of h of x equals 4 over x minus p, or x plus p plus q. They're going to try and throw you off balance. They're going to try and side tackle you with this. Find the equations of the asymptotes. Find the equations of the asymptote of h. Right? 4 marks. Onliners, talk to me, brah. How are we doing? Ndomiso, hi math people. Jay, Dundee, wow. Siabola, so we got Pumalanga, we got Free State, we got Western Cape, Northern Cape, Western Cape, KwaZulu-Natal, Gauteng, Northern Cape Agricultural High School, Landbou, Northern Cape, yeah. Where's that? Namibia, Windhoek. We are good. Minanawe, Mahambi. Abanawe. Let's go. Check this one out. These are our two axes of symmetry. All we have to do, we call this equation 1, we call this equation 2. All they want you to do is solve for x and y. Because x and y are our asymptotes. Remember, in the axis of symmetry, I have to insert the asymptotes. So, if I solve for x and y, all I'm going to say, I'm going to call this one equation number 1. I'm going to call that one equation number 2. I'm going to solve simultaneously. X plus 4 is equal to minus x minus 6. I equate the two. X plus x, 2x is equal to minus 6 minus 4. 2x is equal to minus 10. X is equal to minus 5. That's your p. P is equal to minus 5. Your first equation of your asymptote, that's your 1. Now you put that into any equation. Y equals x plus 4. Y equals minus 5 plus 4. Y equals minus 1. And there we go. These are the two equations of your asymptotes. Easy peasy. It's easy when you know how to do it. Simultaneous. All we did is we solved simultaneously. Onliners, how are we doing? Northwest. Wow, we even got Northwest. All 9 provinces in the house. Well done, Hasanain. Mashallah. Well done. It seems like we're getting bigger reach every year. And next year, we love you too. Wantarena Secondary. Every year, our reach is just growing, guys. And next year, we are celebrating a decade of intervention. 10 years. It's 10 years of intervention across South Africa. Like I told you, we used to go to Ezakeni, Mandeni, Kwadukuza. Those were the great days. That time we couldn't beam. And after COVID, now we're utilizing all this technology to reach the masses of South Africa. So welcome to the K-Way Awqaf program. Right, here goes. Now I'm going to hit you for something that some of you never saw before. Check this one out. a higher order. This one is Mike Tyson. Now, heavyweight. You ready for Tyson? The original OG. Right, so here's a Mike Tyson. H of x is equal to x plus 2 over x minus 5. Question number 1. Rewrite h of x in the form y equals a over x minus b plus q, and hence find the equations of your asymptotes. 5 marks. Question, answer. How many of you have seen this question before? Few of you. Few hands, maybe 6 hands. The rest of you haven't. I've seen this in a grade 11 final paper, and I've seen this in grade 12. I've even seen this in an NBT exam. They're telling you this is a hyperbola with a shift in asymptotes. They're telling it to you. They want you to rewrite this in that form. You see, that's why you come to these programs. These programs make you strong in maths, so you can see what's going on. Onliners, how many of you have seen this one before? Raisa Gangan, number Timor Secondary, that's Azadfur. Welcome. Wahid Gul, Northern Cape. Umlazi, welcome. Check this one. I've seen this question before. Naseko, you've seen it. Brace is the Hulk in math. Beautiful. Right, let me show you how to crack this one. Shh. Watch. Pay attention. All you do, you say h of x is equal to, pay attention. We take the denominator, we put it there, copy and paste. Now you take it and you copy and paste it on the numerator also. You take the denominator, you copy and paste. Now we need a number here to give me plus 2. Watch here. Minus 5 in my numerator. Minus 5 plus a certain number must equal to 2. So the certain number is going to equal to 2 plus 5, which is equal to 7. So minus 5 plus 7 will equal to 2. Remember, we're just rewriting it. We're not changing anything. So the first thing you do, you take your denominator, you copy and you paste. Then you do this on the side. You say minus 5 plus a certain number must give me that. And then you solve for that certain number. I didn't put x here because I didn't want you to confuse you with this. I just put a question mark. Right, now what we do is we split it up. So h of x is equal to x minus 5 over x minus 5 plus 7 over x minus 5. Now that and that cancels out. I'm left with 1 plus 7 over x minus 5. There we go. A over x minus b plus q, which is 7 over x minus 5 plus 1. That's h of x. There we go. We've rewritten it in the correct form. So therefore x is equal to 5. The equations of your asymptotes, x is equal to 5 and y is equal to 1. And there we go. You'll get 5 marks for that. Learn. Know. Are you guys enjoying it? Are you guys enjoying it? Are you guys enjoying it? Lovely. On the session? Are you dull in maths? Are you cracking maths with us? Are you fired up for maths with us? Come guys, you are enjoying it, lovely. Now let's take, how much time, where are we, what's our timing looking like? Okay, so let's take a question here. I came across a question yesterday. Okay, here we go. Take this down and learn it. Take this one down and learn the process, learn the procedure. Right, so here goes. I'm clearing the frame. Right, watch this. Watch this. Right, take this one down. I give you that. I give you that. Take this one down. Here we go. This is an exam scenario. Right. This is graph F. This is graph G. And let's put it in a different color here. And that's graph H. Okay, let's give you coordinates. And let's have fun here. Let's have fun. Let me give you another graph. I'm even now going to give you another graph going like that. And F, G, H, J. I can put every graph all compounded on one graph. Makes no difference. It's all easy. Right, let's go. That's point A, that's point B, that's point C, that's point D, that's point E. And I give you another line coming down here. I'm trying to make it as hectic for you as possible. A, B, C, D, E, let's call this N. I tell you that's 90 degrees. Right, let's go. I tell you f of x is equal to x squared minus 2x minus 8. G of x is equal to ax plus q. Right. I tell you h of x is equal to m over x minus p plus d. I tell you j of x is equal to a over x. I also tell you that E's coordinates is minus 6 and 10. Let's have fun. Let's have fun. I can ask you up to 50 marks, 50, on this. It's so much, it's easy. If the answer is not on the graph, it must be, so there's only, look here. There's two questions you need to ask yourself in your brain for each of these questions for this type. What is it that they're asking, and then how? Like where to find it. If the answer is not on the diagram, it must be in the equation. If it's not in the equation, it must be on the diagram. It can't be anywhere else. You must just identify what is each of these points. What is A? X-intercept. What is B? X-intercept. What is D? Y-intercept. What is C? Turning point. D is also the point of intersection of your hyperbola with the shift in asymptotes. Right. And let's give you this point here on the top. Let's give you one more point. I'll tell you this point here. This is point, I don't know, R. And let's say R's coordinates is 0 and 4. Right, let's go. What is R? R is the one asymptote. C is your other asymptote, and it's also going through the turning point of your parabola. Not only is it the asymptote or the turning point of the parabola, it's also the asymptote of your hyperbola with the shift in asymptote. What is graph F? Parabola. What is graph G? Straight line. What is graph H? Hyperbola with the shift in asymptote. A over x minus p plus q. It's the same thing. And this is your standard hyperbola. Right, now if I understood what each one means, question number 1. I want the length of AB. I want the length of AB. Now what is A? Here's it. What is and how? What is A? What is B? My two x-intercepts. How do you find x-intercepts? Let y equal to 0, am I right? So here goes. Let y equal to 0 on your parabola. So x squared minus 2x minus 8 equals to 0. X minus 4, x plus 2 equals to 0. X is equal to 4 or x is equal to minus 2. So that must be 4, that must be minus 2. Therefore AB is equal to, distance can't be negative. That's minus 2, so that's 2 plus 4 is how much? 6 units. There we go, you'll get your first 3 to 4 marks. Marks for Mahala. Are we all good? Onliners, how are we doing? How are we doing? Onliners, how are we doing? They vibing, they on fire here, bruh.
I smell a distinction.
I smell hundreds of distinctions, thousands of distinctions. The room is reeking of distinctions. Right, question number 2. I want the coordinates of C, the turning point. Now obviously the answer is not here, the answer must be in the equation. So how do we get it? Minus b over 2a and 4ac minus b squared over 4a. From yesterday, do you remember? We already know what the answer to this from yesterday was. What was it? 1 and minus 9, do you remember? Yes, so C is 1 and minus 9. You can substitute A, B and C from here. Those of you who just joined us today, we did this question yesterday, so I just skipped the substitution part. Question number 3, I want the equations of, I want the equations of the asymptotes of H. Question number 3, I want the equations of the asymptotes of H. So obviously in my answer, x is equal to 1. Y is equal to 4. Remember, x equal 1. Not only is this the turning point, it's also the asymptote. So x equal 1, y equal 4. Right, now give me the equation. The next question. Fine, let's see, you can start on your own. You don't even need to wait for me. Start with the equation of h. Start with the equation of h. I want the equation of h. I want the equation of h. I want the equation of h. So we're answering, what number is this? Question number 4. I want the equation of h. So y equals m over, there's it, m over x minus p minus 1 plus 4. Now let's find another point on this graph. We need another point on the graph for x and y. Where are we going to find the other point? Come on, guys. Where am I going to find the other point from? Point D, bruh. Point D is a common point. Remember, D is also the y-intercept of this graph. D's coordinates is minus 8. D's coordinates is 0 and minus 8. D is minus 8. Remember, D's coordinates is 0 and minus 8. From the parabola. But the parabola and the hyperbola cut at the same point. So I'm going to use D's coordinates for x and y. So y minus 8 equals m. X is 0 minus 1 plus 4. Minus 8 minus 4 minus 12 equals m over minus 1 is minus m. M equals 12. So we want the equation of h. So h of x is equal to 12. We found m. M is 12. M is 12 over x minus p, x minus 1 plus d plus 4. Plus 4. Guys, are you following? Good. I will find A and Q. Find small a, find small q. Okay, this can't be A. We have to change this one's alphabet here. So A, give me another alphabet. What alphabet you want to use? A, B, C. Let's call it small e. We can use it as any other alphabet. Right, fine. The next question, find A and Q. What is A, what is Q? Find A and Q. So the next question, question number 5. Find A and Q. That is here. A is your gradient, Q is your y-intercept. And it also cuts through the same point. So we know Q is equal to minus 8. We know g of x is equal to mx plus c. What was the shortcut of finding m yesterday? Wasn't it change the sign of y over keep the sign of x? Do you remember yesterday? So minus 8 will become plus 8 over 4. What is 8 over 4? 2. There we go. Can you see how we're using yesterday's process, the shortcut, to find the answer here? So here we go, 2x, changing y over changing x, 2x minus 8. Then go back to your equation and change it, 2x minus 8. Can you see how we're filling in all the blanks? Maths is a game. Maths is just a game. We're filling in the blanks with numbers. Find the equation of j. Next question, find the equation of j. I want the equation of J. I showed you the shortcut yesterday. J of X is equal to E over X. So J of X is equal to something over X. What did I teach you yesterday? Just multiply those two coordinates. Minus 6 times 10. Minus 60 over X. Finish. Can you see how we're using yesterday's shortcuts to answer this? I told you you're going to love functions. You're going to wait for functions to come up in your paper. Onliners, are you loving it? Are you seeing how everything, are we putting everything into perspective for you? Lovely guys, lovely. Can you see we're using yesterday's shortcuts. We're using yesterday's shortcuts that I showed you in today's exam scenario. Now come, I can ask you domain, I can ask you range, I can ask you equations of asymptotes, the equations of axis of symmetry. There we go. There we go. There we go. That's how you get your A. Right. There's your functions, guys. Now, go and have fun with your past papers. Do we only multiply the two when there's no shift? Yes. Yes, only for a standard hyperbola. A over x, not a over x minus b plus q. Only when there is no shift can you multiply the 2 points. Right, let's go into analytics, guys. Let's give you a scenario, let's give you something. Come, let's clear the frame. Paper 2 analytics. We will finish at 10:30 on the dot. Breakfast is in 30 minutes time. Right, here goes. Take this one down. Here's an exam scenario. Let's give you a graph that goes, let's give you a diagram that goes like that. Like this. And like that. I call that my y-axis. I call this my x-axis. Let's call this point P. 10 and 20. Point Q. 2. Now let's call it 4. 4 and negative 8. And let's call this point R, PQR, minus 12 and 2. Okay. I tell you, this angle here is angle alpha. I tell you that angle there on the top is angle theta. Question number 1. Question number 1. Is PQ perpendicular to RQ? Is PQ perpendicular to RQ? Show all calculations. For 4 marks. Number 2, find angle alpha for 3 marks. Question number 3, find angle theta for 4 marks. Question number 4, I want the equation okay, PQRS. I want find the coordinates of S. Find the coordinates of S. Four marks. I want the if t, x and y is in the second quadrant, and makes PQRT a rhombus. Find the coordinates of T. For 4 marks. 4, 8, 12, 16. Let's make this 5 marks. And that will give me 20 on the dot. Here's your 20 marks, guys. Here's 20 marks. There's 20 marks for analytics. Now, before we even start, what are the formulas that we need to know? What is our toolbox for analytics? Now wait, we'll come back to this. Let's just go into our formulas. I'm coming back to that. Don't stress. Right, distance or length between P and Q or A and B, 2 points, is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Right. Then the gradient formula. We say the m of AB. We all know y2 minus y1 over x2 minus x1. For parallel lines, we know that the gradient of line 1 must equal to the gradient of line 2. For perpendicular lines, the m of line 1 times the m of line 2 must equal to minus 1. Yes or no? Yes. Right, pay attention. For angle theta, we know the angle of inclination. Tan theta is equal to the gradient of the line. We always use tan. We don't use sine, we don't use cos, we always use tan. And it's always from your x-axis. So make a note of that. So you got your first formula, your second formula. Your third formula is your midpoint formula. X midpoint is equal to x1 plus x2 over 2. And the y value of your midpoint is y1 plus y2 over 2. And then you have your equation of a straight line, equation of a line. We know y equals mx plus c. Or if you're given a point and the gradient, you can use y minus y1 equals m into x minus x1. When the gradient and a point is given, when gradient and a point, any point given, both is the same. You can use that one or use that one. I like using that one. So take this down. These are your formulas. These are the only formulas you'll be using. And obviously if it's a 90-degree triangle, area, they might ask you for the area, half base times perpendicular height. Later on in the year, when you do the area rule in trigonometry, for non-90-degree triangles, which we're not doing today, you'll know how to do that. So for now, take down the formulas, and then let's use those formulas to get full marks for the analytics. It's easy, guys. Just substitute. No How do I find it? Substitute algebra. Thumbs up. Onliners, come, take these formulas down. You need to learn. Memorize these formulas. Memorize the formula. Learn it by heart. You don't see me using a formula sheet here because we need to know which formula goes where. Imagine you're building a house and every time you need to use a hammer, you need to read the instruction. Please pick up the hammer. Please use the flat side. Then you must be stupid. Every time you use a drilling machine, please make sure it's on forward, not on reverse. Please plug in. Please hold. You'll be the stupidest builder in the world. Right, here goes. The fun is going to start after break when I start with the exam type trigonometry, reduction, general solution, identities, triangles. Some of you are screaming there, you know, it's going to be easy. Easy. I'll show you how to do it, don't worry. Okay, let's go. Clearing the frame, you got the formula, let's go back. Is PQ perpendicular to RQ? So for perpendicular lines, the M of line 1 times the M of line 2 must equal to minus 1. So let's find the M of line 1. So PQ. Now we're finding the M of this line here. So the M of PQ, I'm just doing my answers here at the bottom. Answer to question number 1. Quiet. I'm just answering it here at the bottom, guys. Let's do the answers here. The M of PQ is equal to Y2 minus Y1, PQ. So let's just call this X2, Y2. Y2 minus Y1 over X2 minus X1. 20 plus 8 is 28 over 6. 2 goes into there 14 times, 2 goes into there 3 times. The M of RQ, so now the M here is 14 over 3. The M of this line is 14 over 3. Now we're going to find the M of RQ. M of RQ is Y2 minus Y1 over X2 minus X1. I get 10 over minus 16. 2, that's negative. 2 goes into there 5 times. 2 goes into there 8 times. Now 14 over 3 multiplied by minus 5 over 8 is not equal to minus 1. Therefore, not 90 degrees. Yes or no? Full marks there for you. But now, let's just put it in. There's a reason why they asked us to find it. We probably will use it later on. So let's put the M of this line is equal to minus 5 over 8. So we don't want to do double calculations later on. Are you guys with me? Good. Yay. Find angle alpha. You see? That's why we had to find the gradient here also. Because now we need to find angle alpha. So let's go. I'm erasing here at the bottom. We're just using the formula from our toolbox. Plug and play. Plug and play. Let's answer question number 2. Angle alpha. Tan of angle alpha is equal to the M of PQ. Yes. Let me see, where's my calculator? I didn't need to take it out today. Where is it? I don't find it. Here we go. Right, so let's go. Tan of angle alpha. Tan. So now we go shift tan because we're looking for an angle. 77,9 degrees, which is approximately 78 degrees. Right, now this is an acute answer, it's less than 90, and that is an acute angle, so we know we're right, we leave it. Alpha is 78. But if I got an acute answer and this was an obtuse angle, we'll just say 180 minus, because angles on a straight line add up to 180. Yes. So that's 78. So there we go. We got our first 4 marks. 4 plus 3 is 7 out of 20. Some of you are just passing already. You have just broke the 33% mark. Don't quit. We're not here to pass. We're here for distinction. Destination, distinction, remember. We want 100%. We're not accepting anything less than that. Find angle theta. Now watch here. Come I show you a trick. Come I show you a trick. Angle theta is here in the air. There. Pay attention. Inclination is calculated from your x-axis. So what you can do, watch here. I can extend this line right down till my x-axis. Pay attention. The gradient here and the gradient there is going to be the same. So I can call this angle beta if I want. So you got alpha, beta, theta. I can calculate this angle. And this gives me one big triangle. Let me highlight it for you. Let me highlight it. We got that. We got that. And we got that. So now I can say exterior angle of a triangle is equal to the sum of the interior opposite angles, because we got this as 78. Remember, we got this as 78 degrees. I only need angle beta. So watch here. Tan beta is equal to the M of line PR, because it's a straight line. So tan beta is equal to y2 minus y1, y2 minus y1 over x2 minus x1. So tan beta is equal to 20 minus 2 is 18 over 22. Beta is equal to shift tan. Shift tan 18 over 22. Boom! 39,28. 39,3. 39,3. Therefore, angle theta. Therefore, we know that angle alpha is equal to angle beta plus theta. Exterior angle of a triangle. Exterior angle of a triangle is equal to the sum of the interior opposite. So what is alpha? 78. What is beta? 39,3 plus theta. So theta is equal to 78 minus 39,3, 38,7. And there we go, that's your final answer, your next 5 marks. So 4, 3, 7, 7 and 5 is 12. You got 12 out of 20. You got 60% so far. Find the coordinates of S. Come, we're almost there, guys. We're almost there. I'm not going to do 100 analytics examples. This is a topic you can score full marks in your exams. We got 10 minutes to answer the next 2 questions before we go for breakfast. Onliners, right, don't wait for me. You start with number 4 and 5. Start with number 4 and 5. Yes, Arsenal, distance, midpoint, gradient. Distance, midpoint, gradient, and the Let's go, let's go, let's go, let's go, let's go. Let's go. Thank you all for participating. Thank you all for all your comments. Lovely to see all of you fully engaged. Remember, this is history in the making. You are part of a historic event. This is the only math tutoring live session where everybody gets to participate in the country. There isn't another program like this. Yes, there are programs on TV. There are programs at your universities. There are programs at your schools. But there isn't one single program where the entire country is engaged in the same program. And you guys are part of history. Right, here we go. Let's go. Right, I'm done with that. Find the coordinates of S. Who knows how to find the coordinates of S? Who knows how to find the coordinates of S? It's very easy. Right, let me show you. We know, listen, we know that the x coordinate for S is 0. We don't have its y value. So if I found the equation of this line, PR, and I substituted 0 for x, won't I find y? So let's find the equation of PR. Let's find, or didn't I find the gradient of PR in the previous question? Yes or no? Yes. We know that the gradient of this line is equal to how much? What was it? How did we get this 39,3? In the previous one, what was it? Talk to me. Can't hear you? I can't hear you. Alright, let me try it again. Okay? Whether we want to use, so let's use the gradient. Let's use the gradient of this line. The gradient, the f of PR is equal to y2 minus y1 over x2 minus x1. That is equal to, I'm using PR. So that is 18 over 32. No? y2 minus y1 over x2 minus x1. Did we make a mistake there? So then y2 minus y1 over x2 minus x1. So it wasn't over 22, it was over 32. 20 minus 2 is 18. What the hell, man? Cheap drugs. is equal to 9 over 11. I'm using the gradient form. So 20 minus y over 10 minus 0 is 10 is equal to 9 over 11. Let's cross multiply. I'm just erasing that. That was the gradient that we found in the last one. Let's do the algebra. Let us do the algebra. So 11 into 20 minus y is equal to 9 times 10 is 90. 20 times 11 is 220. Minus 11y is equal to 90. Minus 11y is equal to 90 minus 220. Minus 11y is equal to 90 minus 220 minus 130. Y is equal to, here's S's, Y's coordinates. So we know S's coordinates is 0 on my X. And now let's find out what's each Y. So 130 divided by 11. We're leaving it as 130 over 11. 130 over 11. Don't use decimals, leave it as 130 over 11. And there we go, we got our next 4 marks. Right, let's go. We're on to the last question. So the 130 over 11, let's take the 130 over 11, 130 over 11. There we go. Are we all good, guys? Good. Start with the last question. We got 5 minutes left and we're moving exactly on time. How many minutes? 2 minutes. Alright, so you better start working. You better start working. Online is how we doing. I hope you're loving the session. Asamein, how we doing there, guys? We good. MashaAllah. S wasn't the midpoint. S is not the midpoint. They didn't tell you it's the midpoint. Right, let's go. If T, X, and Y is in the second quadrant, so where's T? T is somewhere there. Watch here. T, X, and Y is in the second quadrant, such that it makes PQRT a rhombus. So, PQRT is a rhombus. Find the coordinates of T. Let's do it together. So whenever they give you a parallelogram, whenever they give you a parallelogram, and they don't give you the X and Y, use the midpoint theorem, the midpoint formula. You know why? Because the diagonals bisect each other. Pay attention. Don't use gradient, don't use distance. Use because that diagonal and that diagonal meet at the common point, the midpoint. So to find T, I'm going to find the midpoint of RP, the midpoint of PR. And that is going to be X1 plus X2 over 2, Y1 plus Y2 over 2. 10 minus 12 minus 2 over 2, 22 over 2, minus 1 and 11. Right. Now we want to find, so that's the midpoint. Now we got the midpoint, now we need to find the coordinates of T. T's coordinates. X midpoint is equal to X1 plus X2 over 2. Y midpoint is equal to Y1 plus Y2 over 2. What's your X midpoint? This is X midpoint. X midpoint, Y midpoint. X midpoint minus 1 is equal to X. Now we're going to have to use this point. We can call that X2, Y2, right? X1 plus X2 plus 4 over 2. Y midpoint 11 is equal to Y1, which we need to find, Y, plus Y2 minus A over 2. All we do now is we solve for X and Y. Minus 2 equals X plus 4. X is equal to minus 2 minus 4 is minus 6. And 22 is equal to Y minus 8. Y is equal 2 plus 8 is 30, and there is t's coordinates minus 6 and 30. So t's coordinates is negative 6 and 30. You answer it exactly the way I did it on the screen. You don't change anything. It's a template. Learn this template. You're going to be using it this year and next year. Everything I told you yesterday, you have to remember it for grade 11 for 2024 and 2025. Half of next year's paper is grade 11 work. Boys and girls, 10:31. Okay, we went 1 minute over. Hope you guys enjoy your break. I'll see you guys back. Bums on C at 11 o'clock. Onliners, enjoy your breakfast. Loving the session, Zodwa. Brace. Thank you, Antiswa. We replied to all some of your comments. Well done, well done, well done. Enjoy your break. I saw in the house the vibe coming in from the rest of the country. I'm not getting a strain. I can't hear you.
Hassanin, you are inaudible. We can't hear you.
Change of mic. Do you hear me now, Khalid?
Yeah, I can hear you now.
Okay, there we go. As I was saying, sorry about that brief interlude. So yes, Khalid, this is Maths Paper 1. We just finished session number 1. And Mr. Khota and Mr. Zafar Ahmed and his team, they are coming and hosting the session live from Falaah College in KwaZulu-Natal. And we have a broader audience that has logged on via Awqaf's YouTube platform, on Awqaf's YouTube and Facebook platform. Yes, it's been a fun session. So if you have missed out on Maths Paper 1 yesterday, these sessions are hosted on YouTube's platform. Khalid, how's things happening on your side? Khalid is here in Cape Town with me, but Khalid will be shortly relieving me. Khalid, how's things on your side? Have you been following some of the comments and some of the vibe that's been taking place here with Mr. Khota and his cohort in KwaZulu-Natal?
Judging on the comments, Mr. Khota is on fire today, as always. As we all know that Mr. Khota is always on fire, but you need that drive. You need those charts coming with the students, telling how they're feeling, engaging, trying to solve all the maths problems that Mr. Khota is throwing at them. In as much as Mr. Khota will say to them that he has thrown them at the deep end, but it seems like the students are enjoying it online.
Yes, no, definitely, and they're quite sharp. They're actually keeping Mr. Khota on his toes. Yesterday I think there was just like a zero or a minus that was out of place. So some of the learners that was part of the in-person cohort was able to point that out. So with the 400 learners that's presently at Al Falah, they've been amazing, as well as our online cohort of learners. Please hit us up in the comments. Let us know if you are enjoying this program, and tell us if it is correct that we are smelling lots of distinctions from all of you that are joining us. So tell us, Khalid, later on you've got some special guests lined up for us. Please give us a preview of what to expect later on in the program.
Yes, later on the program, inshallah, we'll be having Sister Tandi Modise, who will be joining us, a former grade 12 learner, who was introduced, to this platform by their teacher, and their teacher also, Mr. Clement, also will also be here with us, Mr. Clement Gobeni. and we'll be chatting to them, in order to check, how is it and what is it that they have benefited. And it's quite encouraging, to organize such initiatives and platforms like this one of Awqaf, and to see the response, that is coming not just from the students who are online at the moment, but you also have something to show for this kind of programs. You have products, people whom you can point out and say that they benefited. It gives us the energy to do more. It gives us the energy, to engage more and keep on doing these initiatives. And also, it encourages the students, who are online, those who are still doing this maths workshop and who are part of this platform, to say, check, there is someone out there who has succeeded out of this. So why not?
So there we go, halala, halala. So this workshop and this effort has been taking place for the last 9 years and is hosted by OCAV, and Mr. Khota is the maths facilitator. We work jointly with the Department of Basic Education, iSkill. We always have a host school, and this time around it's Falaah for the grade 11. So with this joint collaboration, we are able to play our part and contribute towards providing quality education in South Africa. Education and achieving or performing well in your education opens up many doors for your career. Would you agree, Khalid?
I do agree, because what we've seen now is that the students, are mostly focused on passing the subject. There is no love for the subject at all. And I think with this platform and this initiative from Awqaf, what it has done, it has transformed mathematics from a subject into a love of their lives. And you can see the students are enjoying, this platform. They're enjoying doing maths workshop. And when I've been talking to some other people as well about this workshop, they were quite surprised that there was an online platform whereby they can learn mathematics, and they were quite happy about it, to such an extent I ended up giving them the link, to join us and be part of us. And I must say, with the expertise of Mr. Mohammed Khota, and he has taken mathematics to a whole new level. It's not just a subject now, it's a love of their lives. They are enjoying it, the jokes, the humor that comes with it. So there is no dull moment in these platforms.
Yes, certainly, Mr. Kota, in his own unique brand of quirky humor, actually contributes towards enthusiasm amongst the learners. And what we also find in Khalid, there are quite a few educators that are joining the session because they are deriving benefit in terms of acquiring new teaching methods, and also there's this need to constantly innovate um, with regards to teaching mathematics. Mathematics, the comprehension of it for some learners, there is a little bit of a stumbling block. But yeah, be it as it may. So I'm going to be handing over the shift to Khalid Romano. He will be moderating the comments at the back, and he will also be vibing with the learners and interacting. So please interact with Khalid and show us some love. So Khalid will also be putting on a QR code on the screen later on. If you are a participant, a learner, that's by the means, or your parents, you can contribute to OCAF's education workup. We do have a charitable endowment fund, and this fund allows us to assist learners with the mathematics at no cost whatsoever. So these workshops are hosted free of charge, but we would like to extend and help more learners. So by contributing to the education workup, you can use your smartphone, you can scan in that QR code, and this will take you to our website, and you can make payment via a credit card. You can log on to awqafsa.org.za. There's an easy to use donation option. So, and also, if you are logged on to the YouTube platform, in the chat, there's a little dollar sign, and that's a super chat. So anything from 50 Rand, 100 Rand, 1,000 Rand, 10,000 Rand, you can give us a super chat,
and these funds will be invested in our education Awqaf, our charitable endowment, so we can assist more learners and the educators. It's over to you, Khalid. We'll speak to you later. Enjoy the show.
Just before you go, I need to compliment, you've got a nice camera today and you are nice and clear. The sound, everything is on point.
Yes, no, definitely. I think we had, as always, with this platform, we want to bring the best production for our learners and making it
Yes.
conducive for them to learn. But with the scheme of things that this platform and the technical needs is always in a state of flux. So you're always going to experience or have some issue around sound or video. So yes, I was able to sort out some of the gremlins that crept into my system yesterday. I'm able to use the lighting, the camera, and so on. So and same on your side, Khalid. I think your audio and your visual is coming through clearly. So we always have an emphasis on adhering to some of the technical pillars to bring you the best production possible. So yes,
Oh,
that's it from me. Khalid will be taking care of you. Thank you for that compliment, Khalid. You are way too kind.
shukran. Salam alaikum. to the Awqaf paper to Maths Workshop with Mr. Khota. So we give you to Mr. Khota now. Mr. Khota, take it away.
Let's get this started up. Here we go, here we go, here we go. Khalid, are we loud and clear? From our space orbit, we all good? Khalid, give me a thumbs up. We good to go? Loud and clear? Sound, picture, everything good?
Everything
Lovely.
Khota.
Guys, we are back in the ring. We are back in the MMA ring. The MMA for mathematics. So don't be corner. This is title fight round 2. And in the corner, coming in at 150 pounds. You got the grade 11s. And coming in at 300 pounds, you got math paper 1 and 2. Let's get ready to rumble. Welcome, welcome, welcome back. Title fight, title fight. This is Habib and corner. Don't tap out, don't be corner, be Habib. Well, Alhamdulillah. Alhamdulillah, let's go. Patiently waiting for the diabolical Euclidean. Satan, you know, Euclidean is Satan. It's coming. So welcome everybody, welcome, welcome, welcome back. Are we live? We are back, and this one, give us a thumbs up. You guys can hear us and see us clearly. We are starting with trigonometry session 2. Let's go, let's go, let's go. Ding, 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 ding. Let's go. Right, here we go, here we go, here we go, here we go. Come on, clear the frame. Let's go. I see we got a bit of a delay here with Google. Right, let's go. Thank you, thank you, thank you. Let's go. We are starting with trigonometry. Trigonometry. Coming in at 300 pounds. Going to give you a left hook, pop and wave. Jab, jab, June, July. The first thing we need to do is solving using a sketch. Number 2, we need to know reduction. Wyatt. That's your special angles. (30°, 45°, and 60° angles. Then we've got identities. So sketch, simplify, prove. So that's why things is so easy. If it says simplify, it's reduction. If it says use a sketch, it's Pythagoras. Identity is proof. Trig substitution, I'll show you what that looks like. Example, they tell you if sine 21 equals P, find blah 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 in terms of P. Or M or A. And then we have what we call general solution. And that's where we're solving. We either give the general solution or we solve for X. Or solve for theta. Now you're going to get one of each in every paper, and that's what's going to make up your entire trigonometry component for paper 2. 40 marks, and obviously you've got your trig graphs. Okay, so here we go. Here it will say solve, or it will say give the general solution. And then you got your trig graphs. This here will be about 40 marks. That's what you got to know. This is your checklist. If you know this, you know trigonometry. Onliners, how are we doing there? Talk to us. Let's go. Khalid, how are we doing? Our guys vibing with us there, guys. Khalid, talk to us. Hey, Professor. Hey, Grace. I'd love to meet some of you guys at the point in our lives. I hope we cross paths.
Everything is okay, Mr. Khota.
Lovely, I can hear you. You're coming through loud and clear. How's our guys on that side? Are they vibing with us? They're Khalid?
They are vibing with us, Mr. Khota. They are waiting for you to go.
That's it, that's it. Title 5, Baba, title 5.
Round 2, let's go.
Round 2, let's go, Baba. Let's go. We're going to kick trigonometry hard. We're going to drop him. KO. TKO. Trigonometry KO. Let's go. It's battle of the mind, guys. It's a battle of the mind. Same battle, different arena. One is physical, this is mental MMA. Mental math in action, MMA. How's that for a new acronym? We're going to change MMA to mental math action. Quiet then. Let's go. Right, so you've got all of this, let's get started. Now you're going to love this topic. I'm not asking you, I'm telling you you're going to love it. You know why? Because I got shortcuts, I got acronyms, I'm going to summarize everything for you. I'm doing all your dirty work. Leave it to me, that's my job. Your job is just to learn and practice. Now pay attention. Pay attention. You pay attention in this section. You're going to get full marks. You're going to love trigonometry. Trigs will become one of your best and one of your favorite topics. Pay attention. Let's start with a sketch. Let's start with sketching. I'll show you how to do that. Right, so we're going to go through this. We're going to do a couple of examples of each. So watch here. They give you something like this. They give you that. Watch here. Watch here. They tell you, they give you a line here, that's 0, that's P, that's -3, that is 5. They tell you this angle here is angle alpha. Right, quiet, pay attention. So you're given this in your exam. So you open up your trigonometry paper 2, that's what you see. They tell you, find question number 1, sine alpha. Question number 2, find sine 90 minus alpha. Question number 3, find alpha. Okay, here goes. Right, let's work this one out. Now, what is the method? We need to know the method, so let's go through the method first. Right, I'm going to give you an acronym. Listen. Right. So what we do is step number 1, you drop your perpendicular against your x-axis. Against your x-axis, that's where you drop your 90 degrees. Never against your y, against your x-axis. So what are we going to do? Step number 1, we drop our 90 degrees. Now you put x and y. Insert x and y. So that's x, that's y. X is -3, y is 5. Now we use Pythag to complete. So let's use Pythagoras. Now we need the hypotenuse, OP. So maybe they could even ask you find OP first. So use Pythagoras to complete OP. So we need OP. That's our hypotenuse. So we're going to start h squared is equal to -3 squared plus 5 squared. Pythag. H squared is equal to 9 plus 25. H squared is equal to 34. H is equal to square root of 34. So there we go, square root 34. There we go, we've completed the diagram. You always do that. You drop your 90 degrees against your x-axis, never against your y. Right, now let's find sine theta. Now you just use shortcut just use SOHCAHTOA. Sine alpha is opposite over hypotenuse, so you go to your diagram. That's your angle. You always work with alpha inside your diagram. That's your opposite. That's your hypotenuse. That's your adjacent. So sine, answering question number 1, sine alpha is equal to opposite over hypotenuse. Opposite over hypotenuse is 5 over root 34. That's where you leave it. That's where you leave it. You don't touch it. No decimals here. Leave it insert form. If you did convert it to decimals, no problem. If they said without the use of a calculator, you just leave it as 5 over root 34. Are we all okay with it? Do we get a thumbs up? It's easy. Complete your diagram first. Then answer the question. Number 2. Sine 90 minus alpha. Question number 2. Sine 90 minus alpha. We know sine 90 changes into cos alpha. Yes or no? Yes. And we know that 90 minus is in your first quadrant. Sine in your first quadrant is positive. Yes or no? Yes. So we leave this as positive. So cos alpha, we know, is adjacent over hypotenuse. So adjacent over hypotenuse minus 3 over root 34. There we go. But be careful if they told you sine 270 minus alpha. Let's say they asked you for sine 270. Let's say, for example, they asked you for sine 270 minus alpha. Now sine 270 will change to cos alpha. You know 90 and 270 changes the name. 270 minus is in my third quadrant. Sine in my third quadrant is negative. Yes or no? Yes. Now this would be minus adjacent over hypotenuse minus 3 over root 34. Your answer would just be 3 over root 34. Are you all okay with that? Please check your quadrant. Please check your quadrant. 270 minus 270 minus is in quadrant number 3. And you look at the original. And now let's find angle alpha, the last one. So we can use sine, cos, or tan. What do you want to use? It's up to you. Let's answer question number 3. Let's use sine. Sine alpha is equal to 5 over root 34. So alpha will equal to, let's go, shift sine. Shift sine. We use the shift key on the calculator because we're looking for an angle. Shift sine. 5 over root 34. 59,03. But remember, that's that angle there, 59,03. This is the angle that they were talking about from the start. So therefore, in this case, alpha is equal to 180 minus. Sum of angles on a straight line add up to 180. They want that angle there. There's angle alpha. 180 minus 59,03. So alpha would equal to, let's do it together, 180 minus 59,03, and that will give you 120,96, which is approximately 121 degrees. And there we go. That's how you do a diagram. That's how you do a diagram. Now comes, I'm going to teach you a certain set of rules that you're going to use for grade 11 and 12. See, we had a learner here I was speaking to during the break, a learner from Orient Islamic School. So Orient in the house, Assalamu alaikum, how are you guys? Thank you for coming through. And this learner said that last year he was scoring 35% in math. And then he attended the K-Way workshops like this and he ended up in his 80s. So these are the heartwarming stories that we are learning from our learners, and if you utilize our methods and our systems, you will get in your for reduction. And if you learn these 5, I've now, you see what happens in schools, you learn one rule, then they give you a question, then you get knocked out because the thing gives you a punch in your stomach, then you fall to the ground. Now you're looking for where the punch came from. Now you're looking for where the punch came from. So I'm going to give you 5 rules. I call it, these are my own. I've summarized it for you. Listen, open your ears and pay attention. I promise you, if you learn these 5 sets of rules, you won't have a problem till the end of grade 12. Because what I've done, I've taken the whole chapter for you and I've summarized it for you on one screen. So the rest of the notes that you have regarding this topic, you can use it as toilet paper. Listen. Listen. Right. Let's talk about whether the name stays or whether the name changes. That's the first set of rules. So let's call it block number 1. So what we're going to do, I'm going to break this up for you like this. Let's do this. Let's summarize it. Because we call it the 5 block rule, let's do this. Let's call it 1, 2, block 3, all you have to do is remember these 5 blocks. You remember these 5 blocks, you'll be able to do any reduction. So I've summarized it for you. Check here. The first block of rules, is what we call the Cartesian plane. Watch here. We know that 90 plus or 90 minus or 270 plus 270 minus, we must avoid using it because the name changes. The vertical line, that vertical line, that's 90, that's 270. Just think of it like an electric fence. You get electrocuted. When you use that name, your name changes. From living, you die. So from sine, you become cos. So from cos, you become sine. The 180 plus or 180 minus and 360 minus, we try and use it because the name stays. So your vertical line, the name changes. The horizontal line, we use. So if an angle lies here, we don't say 90 plus, we say 180 minus. If an angle lies here, we say 180 plus, we avoid using 270. And if an angle lies there, we say 360 minus, we don't say 270 plus. Are you listening? That's block number 1. Block number 2 is what we call the negative angles. Please pay attention to this. This is so important. This is where you guys generally fail or you mess up. Sine of a negative angle is equal to minus sine of that angle. Tan of a negative angle, to remove the brackets, becomes minus tan of that angle. Cos of a negative angle is positive cos of that angle. Cos changes to positive because a negative angle doesn't exist in the world of cos. According to ASTC, 360 minus is here, that's a negative angle, cos is positive. And 360 plus is in my first quadrant, cos is positive. So, you can't get cos of a negative angle. You can get minus cos of an angle, but you can't get cos of a negative angle. It will always be positive. Are you all with me? So learn. The first one, Cartesian plane. Avoid 90 and 270, use 180, 360. Next one, negative angles. The cos becomes positive. The next block, the anti-clockwise angle. Anti-clockwise. So if I told you sine x minus 180. That's anti-clockwise. Normally we'll have 180 minus x. Now you have a scenario in your problem where you see x minus 180. show you a trick. We know sine 180, the name will stay. 180, the name stays. We use sine 180 becomes sine x. Right, now wait, watch here. All you can do is draw a rough Cartesian plane. Sine is in my second quadrant. That's where sine lives. Everyone lives in the first quadrant. Sine cos tan. Sine lives in quadrant 2, tan lives in quadrant 3, cos lives in quadrant 4. Right. Now pay attention. So sine. Now we're going to move 180 degrees anti-clockwise. Watch here. Watch here, watch here, watch here. To determine the sine. So we'll start from here. From here to here is 90. From there to there is 180. So from here, sine decided to go and visit cos. Sine decided to go and visit cos. So what is sine in this quadrant here? And that's how you reduce an anti-clockwise angle. So sine 180 minus x, sine 180, the name stays. Sine lives in quadrant 2. He's going 180, let's say 180 meters or 180 degrees to go and visit his friend Mr. Cos. So he's going from there 180 degrees and he's visiting Mr. Cos in quadrant number 3. So sine in this quadrant is negative. Let's do another one, another example just to show you. I hope you all understanding. I hope you all paying attention. I hope you are all learning. You have to memorize this. You'll see how all this comes together when I start doing the hectic problems. And they're all easy. You'll get full marks for it. So what if I told you cos x minus 270? Right. Cos 270, does the name change or stay? Changes to sine x, yes or no? Where does cos live? In quadrant 4. He's now going to move 270 degrees anti-clockwise. So from here to here is 90. He passes that, he goes from there to there is 180. From there to there is 270. What is cos in this quadrant? Positive or negative? And that's how you change it. Cos x minus 270 to minus sine x. Are you all with me? Learn and remember. The next set of rules. So block 1, Cartesian. Block 2, negative. Block 3, anti-clockwise. Block 4, the square angle. Any angle square is positive. So if I told you sine squared 180 plus x, sine 180 will remain sine x because it's 180. We don't need to check whether it's positive or negative. We know 180 plus is in your third quadrant. But we don't need to worry because anything squared is always. There we go. Let's do another example. There's an example. Here's another example. Let's say cos squared 270 minus x. Cos 270 will change to sine squared x. Do I need to check whether it's positive or negative? No. Why? Anything squared is always finish. That's your fourth set of rules. Remember, this is like a minefield. These are all bombs. There are 5 different bombs. We need to know how to dismantle each one of these bombs. Because when they give you a big problem, all those bombs are there. You're walking on a minefield. And if you make a mistake, kaboom. You blow yourself up, you blow the whole question. So don't mess it up. And the last one is an angle greater than. So we got Cartesian plane, negative angle, anti-clockwise, the square angle, and we got any angle greater than 360. We minus 360 from the angle. Example, cos 480. Now you know a circle has only got 360 degrees, so you must minus 360. So this is cos 480 minus 360 is how much? 120. Now we reduce it. This will become cos. Do I say 90 plus 30 or do I say 180 minus 60? Good. Why? Because I said avoid using 90. If 90 is in the question, no problem. We have to sort. But when you have a choice to use 90 or 180, always use the 180. So this will become 180 minus 60. Now we reduce cos 180, the name stays the same, cos 60. 180 minus is in my second quadrant. What is cos in my second quadrant? Negative. So my answer is minus 1/2. That's how we sort cos 480. Or any angle that's greater than 360, we subtract 360, then we reduce as per normal. Are you all with me? What do we call this? The 5-block rule. I call it, so we call it the K-way 5-block rule. I've summarized the entire topic for you. I've summarized the entire topic for you. Let's start. Let's start. So let's throw you into the deep end. And 5 marks and 5. I'm going to give you 2 questions from the one paper. 10 marks. 5 marks and 5 marks. I promise you, you use this rule, you're going to get full marks. Are you ready? Onliners, are we ready? Onliners, how are we doing? Khalid, how's our guys doing? Are they on fire there? Are they learning? Here we go. Here we go. Here we go. You are ready. Brace, you are ready. I like your name. Brace yourself. Brace yourself, Baba. Brace yourself. I wish my name was Brace. I'm always ready. Let's go. Clear frame. Watch. First one. I'll start you from easy and I'll try and choose some of the most difficult ones. Nothing is difficult. If you learn that 5-block rule, hot knife through butter. Simplify, 2 sine, 180 minus theta. Take this one down. Cos 360 minus theta. All over. Cos 90 minus theta. Times cos 180 plus theta. This is so easy. This is pi. This is a walk in the park. This is nothing. For 5 marks, simplify. You can start. Let me find you a more difficult one. This is easy. Too easy. Start. If you get this one wrong, you're going to fail. I want the difficult one. Come on. I want the difficult one. I don't want easy. This is baby work. Child's play. Child's play. Nice. Okay. Little bit difficult. Too easy. Here's one. That's got a square and a negative angle for 6 marks. Beautiful. You'll check the next one. How we're going to crack it, Baba. The next one. Let's go. Easy peasy. This thing must be done in 60 seconds. You're taking longer than 60 seconds. You don't know your work. Let's go. 2. Do your numerator first. Sine 180, the name stays sine theta, so it's 2 times sine theta. 180 minus is in my second quadrant, we know sine is positive. Times cos 360, the name will stay in cos theta. 360 minus is in my fourth quadrant. Cos is positive. Cos 90, the name changes, sine theta. 90 minus is in my first quadrant, cos is positive. Cos 180 will remain cos theta, sorry, not cos x, cos theta. Right. 180 plus is in my third quadrant. Cos is negative. Yes. So I'm just moving it because you multiply. You multiply and I can put it here. Okay, you want me to put it? It's the same thing, man. Positive times negative is a negative term. Sine, cos. 2 over minus 1. So whether I put the minus in the front of the sine or I put it in front of the cos, don't make a difference. Right. You ready for the big one for 7 marks? Here it comes, here it comes, here it comes. Here it comes. You might get 1, you might get 2. 1 with an angle and 1 with an unknown angle. Right, here goes. Cos minus 180 minus x. Be careful here. Don't take the negative outside. You take the negative out inside your bracket. I'll show you what to do. But anyway, try. For those of you who are smart, try. Tan 360 minus x. Cos squared 90 plus x. All over sine 180 minus x times sine of minus x. For 7 marks, simplify. Take this one down. Let's see how good are you. Again, a problem like this shouldn't take you more than 60 seconds. How's our onliners there, Khalid? Caleb, talk to us. -2, that's the answer. Here we go. Correct, Mundo. You are burning spoke sky. 7 marks here, Baba. 7 marks. Let's go. Fire. Are you guys on fire, guys? Maths is your servant. Deadly phantom. Let's go. Let's go. It's 7 marks. 7 marks. Let's go. Let's go. Let's go. Let's go. Right. Watch what we do here. Watch what we do. You see this? Pay attention. Put your pens down. Don't take out the negative. Leave it as cos. Put a square bracket. And now take the minus into 180 plus x. Take the negative sign out inside the bracket. We're making it a negative angle. So minus times 180 will give me minus 180. Negative times positive will give me negative. Yes or no? So don't take the negative outside. Take the negative outside inside the bracket. Create 2 more brackets. This is how you do it. Please learn. Tan 360. Tan of 360, the name will stay tan x. 360 minus is in my 4th quadrant, tan is negative. Times cos 90 will change to sine squared x. Do I need to check whether it's positive or negative? Why? Squared. Anything squared is always? Very good. Sine 180 will remain sine x. 180 minus is in my 2nd quadrant, sine is positive. Sine of a negative angle is minus sine x. Yes or no? Right, now wait. Let's get rid of this. Cos of a negative angle was what? So now I'm only dealing with cos of this angle. Forget about the negative. Forget about the negative. It's gone. It doesn't exist. Are you listening? Now pay attention. So cos 180 will be cos x. The name will stay. 180 plus is in my third quadrant. Cos in my third quadrant, negative. Now this negative didn't come because of that. This negative came because of 180 plus. That negative in the front disappeared. Gone. Are you listening? Multiplied by minus. What is tan x? We need to convert everything to sine x over. Right, so that's over 1 times sine squared x. Let's break that up if you want, it's easier. Sine x times sine x is sine squared x. I just broke it up, it's easier for us to cancel. All over. Positive times negative is a negative, and then I'm going to just leave it as sine x times sine x. I'm leaving it like that because it's going to make it easier for me to cancel. Right, now let's sort out our signs. 1, 2, 3. An odd number of negative signs is negative. Multiplied or divided. Even number is positive. I got 3 negative. Negative times negative is a positive. Divided by a negative is a negative. So if you got an odd number of signs, it's negative. If you got an even number, it's positive. Right. Cos x, cos x. Sin x, sin x. Sin x, sin x. What am I left with? Done. Done. Right. You all okay with this? Give us a thumbs up. Onliners, are you following? Are we all? It disappears because cos of a negative angle is positive. Cos of a negative angle is positive. That's why the negative disappears. They still asking me why does it disappear? I gave you the 5 block rules. Cos of a negative angle is always positive. That's why. Thank you, thank you, thank you. Specific. You want to do one more example? Okay, here we go, here we go, here we go, here we go. Right. I hope you took this one down. That's clear. Right, simplify. Now special angles. 7 marks. Simplify without the use of a calculator. Tan 135. Plus sine 210 all over cos 660 plus cos of minus 180 for 7 marks. Let's go. Try that one. Let me see if I can find you more examples. I know I got somewhere on my phone. I got some. You guys start with this one. Reduce. Pay attention. The 135, we won't say. Remember, you need to use 30, 45 or 60 degrees. I'm not going to say 90 plus 45. You are going to say 180 minus 45. 180 plus 30. Here I'm going to subtract how much? 360. And cos of a negative angle is what? Cos of a negative angle is what? Right, so start. I'm going to take another one out. Remember, I took another one down. Let's see. Where are we? Boom. Right, I'll do another one like this after that, taken out from my past paper here. Okay, let's go. Onliners, are we working? Where's our onliners there? Yeah, the whole of South Africa is grafting. Three little scrumptious. Beating it, Baba, beating it. Welcome, Barialam. Here we go. Let's do it. So this is equal to 10. Right, listen to me. Do I say 90 plus 45? No. What do I say? Correct. Plus sine 180 plus all over. Cos 660, I'm going to minus 360 from it. So that's cos 300. This is going to give me cos 300. And cos 300 is what? 360 minus 60 plus cos 180. The negative will fall away. Cos of a negative angle is positive. So that will fall away. Now we just do cos 180. So what is cos 180? Cos 180 equals minus 1. Not because of that minus. That minus flew away. Because cos of a negative angle is positive. But cos 180, cos of 180 is minus 1. Now let's reduce. Tan 180 will remain tan 45. 180 minus is in my second quadrant, tan is negative. Plus, or multiply. Sine 180 will remain sine 30. 180 plus is in my third quadrant, sine in my third quadrant is negative. Cos 360 will remain cos 60, the quadrants fall away. But remember, the quadrants fall away after you keep the name or change the name. 360 minus is in my fourth quadrant, cos is positive. Positive times negative is minus 1. Minus. Now you can cheat using your calculator. Tan 45 you know is 1. Minus sine 30 is a half. All over cos 60 is a half. Minus 1. If you want to use a calculator, minus 1 minus a half, minus 1 and a half, minus 3 over 2 divided by half minus 1 is minus a half. Negative divided by negative is a positive, times 2, your answer is 3. Learn. I'll give you one more like this. I'll give you one more like this and we're done with reduction. Then I want to show you, we'll do trig substitution, then I'll show you identities, then I'll show you general solution, then we are done. You'll get full marks for trigonometry. We're moving on good time, it's 10 to 12, before you know it, it's lunch. We'll come back from break for half an hour. I'll show you 3 graphs and we start with Euclidean. I think your guys' food, I think they brought you guys lunch. Right, here goes. Next one. Onliners, how are we doing? Are you guys ready for the next one? Who said 44? Your special angles are 60, 40. I never said 44. Where I said 44? Let's go. Here we go. Let's go. Simplify. Six marks. Let's go. Come on, liners. Come on, liners. You guys are doing well. We did the whole of functions. We did the whole of algebra. We did the whole of what exam questions. And now we did the whole of analytics. We are now doing the whole of trigonometry. That's why I'm telling you it's possible. It is possible to master the whole of maths in 2 days. The whole year's maths is end of the year. Listen, end of the year, we do the whole year's revision in 2 days. Paper 1, we do everything. We do algebra, we do finance, we do number patterns, we do probability, functions. Paper 1, we do it on the Saturday. Sunday we do data handling, analytics, trigs, and Euclidean. We finish the whole year's syllabus in 2 days. It's possible. Let's see who's working, who's on fire here. Let's go. Let's go, let's go. Zodwa, going all good your side. Arsenal, well done. Not 136, 135. Sandika Singh, yes, yes. Let's go. Reading your comments that are coming in. Reading your comments that are coming in. Here we go, here we go, here we go. You ought to be done now. Well done, Mina Nawe Hamdi. She's done, or he's done. Mina Nawe is a male of female. Mina Nawe. Let's go. Cos of a negative angle is positive cos, so it's cos 225 times sine 135. I'm just doing the step here to show you that that negative falls away. Plus sine 330 all over sine 225. Right, cos 225 is going to be cos 180 plus 45. Times sine 135 is 180 minus 45. Plus sine 330 is sine 360 minus 30. All over 10 225 would be 10 180 plus 45. Let's dial up. Cos 180 would be cos 45. 180 plus is in my third quadrant, cos is negative. Sine 180 is sine 45. Sine 360 minus would be sine 30. 360 minus is in my fourth quadrant, sine is negative. Tan 180 would be tan 45. 180 plus is in my third quadrant, tan is positive. So now let's simplify. Minus cos 45 is 1 over root 2 or root 2 over 2. Sine 45 is root 2 over 2. Minus sine 30 is a half. All over tan 45 is 1. Minus root 2 times root 2 is 2 over 4, which is a half. Minus a half over 1. Minus half, your answer is negative 1. Finito, game over. TKO, total knockout. Trigonometry, full set. TKO. Maths is dead. You can't let a dead thing beat you. Right. Here we go, here we go, here we go. Onliners. Did you all get that one right? Minus 1. Well done, Arsenal. Well done, well done, well done. Well done, well done, well done. Okay, now we go into okay, no, let's do that other one where if sine 21 equals b, trig substitution. If sine 21 equals p, find cos 21. Sine, that's cos 21. Sine 101, no, sine 111. In terms of P. Mark educations, 2 marks, 2 marks, 2 marks. Total marks, 6. Quiet. I'm going to show you now a trick to do this. Listen, whenever you see something like this is what you do. Here's another acronym. SCRAP. You use what I call scrap. You scrap it. Let me show you what it means. S means put that into S for scrap, S for standard form, and S also for Socrator. C for Cartesian plane, draw your Cartesian plane. R for restriction, look for restriction if it's given. A is just for add. P is for Pythagoras. Use Pythagoras to finish. So there we go. That's the order in which you do it. Standard form, Socrator, draw your Cartesian plane. Look at your restriction and use Pythagoras. Then answer your questions. You'll get them all right. So we scrap. We use scrap. So watch. Put your pens down. Is that in standard form? No. My right hand side must be a fraction. That's standard form. And katawa, sine is opposite over hypotenuse. So I'm done with S. Cartesian plane, they don't give me a restriction, so I just draw it in my first quadrant. They don't give me a restriction, so I draw that. I put 21 there. Opposite over hypotenuse. There we go. No restriction, and I use Pythagoras to finish it. So 1 squared is equal to x squared plus b squared. 1 minus b squared equals x squared. X is equal to plus or minus the square root of 1 minus b squared. Obviously this is to the right, so this is on the positive side. So it's positive the square root of 1 minus b squared. There we go. Now we are complete with our diagram. Now we can start answering our questions. So what system do we use? We use Scrabble. Just a letter system to use. If you remember all these systems, you'll love it. You'll wait for it to come out in the exam. That's how you get 100%. Remember, maths is not just about doing the problem, it's about knowing what steps to use, and these are the steps. Onliners, are we on fire? Are we on fire? Are we on fire? Somebody is saying they can't see the screen. What's happening there? Enlarge the screen. Are we all good? Are we good? Are we good? Are we good? I'm on full screen here. What's happening there? Cape Town, are we good? Guys, give us a thumbs up. Are you guys alright on that side?
Yeah, we are good. The screen is now enlarged, so I think all of us are good to
Thank
go.
you. Thank you. Are we all good? Are we all good? We all good? Lovely. Let's go. Let's go. Let's go. Right, now let's answer our questions. Right, now you just use Sohcahtoa and reduction. So to answer question number 1, cos 21 is equal to adjacent over hypotenuse. That's your opposite, that's your hypotenuse, that's your adjacent. So cos 21 adjacent over hypotenuse, square root 1 minus b squared over 1, which is square root of 1 minus b squared. There we go, we answered question number 1. Question number 2, sine 111. That is sine. Here we are forced to use a quadrant 90 plus 21. We can't use 180 minus because there's nothing in terms of p. So sine 90 will change to cos 21. 90 plus is in my second quadrant. Sine in my second quadrant is positive. My answer is still square root 1 minus b squared. And the last one, tan 159. Tan 159. Obviously, what's the relationship between 159 and the 21 and a quadrant? It's going to be tan 180 minus 21. That will give me 159. Now let's reduce that. Tan 180, the name will stay tan 21. 180 minus is in my second quadrant, tan in my second quadrant is negative. And tan 21 is opposite over adjacent. So what's my opposite? B. What's my adjacent? Square root 1 minus b squared. Come on. Done. Right. That's quick substitution. That is quick substitution. Let's do identities. I'm going to teach you another way of doing, I'm going to give you another acronym to do identities. These are just methods that you use to fight the beast. The identity beast is coming to raise his head. God of war. Onliners, how are we doing there? Talk to us. The fire is us. No buso. Why did I square 1x and 3? Pythagoras. Pythagoras, no buso. Pythag. The square on the hypotenuse is equal to the sum of the other two squares on the other two sides. That's why we square. Yeah, show us the full board. They want to see the full board. What's happening? Right. That's not on my side. There we go. Here we go. I'm clearing the frame. Cape Town, what's happening? Khalid, are you showing them the full board? Are they seeing the full screen? Right, let's go. Right. Proof. Here's your acronym to solve identities. Right, just remember, Ali. What must you remember? Right, let me explain to you. So Ali does identities. Who's Ali? Let me explain to you. Is too much talking here? Guys, thank you. Right. Ali does identities. AL, step number 1, do your algebra. AL, step number 1, do algebra. Step number 2, look for your identities. Now, what are your identities? Your identities is you know that sine squared x or sine squared theta plus cos squared theta is equal to 1. Yes or no? Yes. Now from here, you just need to remember this, but you also know that sine squared theta is 1 minus cos squared theta, yes or no? Yes. And 1 minus cos squared theta is a difference of 2 squares. Is 1 minus cos 1 plus cos. And then you also got cos squared theta is equal to 1 minus sine squared theta from there. And 1 minus sine squared theta is 1 minus sine theta into 1 plus sine theta. You don't need to remember all of this, they're good to know, but all you have to do is remember that. They are called square identities. Because in sine squared, you can't say sine plus cos is equal to 1. No. Sine plus cos is sine plus cos. But sine squared plus cos squared is equal to 1. And then we know, obviously, what are our other identities? Tan theta is equal to sine theta over cos theta. Or tan squared theta is equal to sine squared theta over cos squared theta. So step number 1, do your algebra. Step number 2, look for your identities. Your left-hand side will equal to your right-hand side. I'll show you how easy it is. We'll do a couple of examples of this. Many examples, no stress. Auna squares. Auna squares. Interesting. Okay. I'm going to take you up level 1, level 2, level 3, right? Let's go. Are you ready? Are you ready to find Muhammad Ali? Let's go and find Ali. Come. Let's go. Ali does identities. Onliners? Who does identities? Onliners? Who does identities? Let's hear our onliners say. Ali does identities. Step number 1, algebra. Step number 2, look for your identity. Game over. Left hand side will equal to right hand side. Here goes. Proof. Pay attention. Proof. Let's say sin x plus cos x all squared is equal to 1 plus 2 sin x cos x. For 4 marks. Answer. We start on the complex side. So we start on the left hand side. Pay attention. In algebra, how do I remove brackets? So it's sin x. I'm doing C from Ali. I'm doing the algebra. Sin x plus cos x into sin x plus cos x. That's algebra. That's algebra. Ali does identities. Algebra. Let's remove the brackets. Sin times sin squared x. By 2 first, by 2 outer, plus sin x cos x. My inner, plus sin x cos x. I'm doing algebra. I'm not doing trigonometry. Plus, cos times cos is cos squared x. Right. So now simplify this. I'm left with sin squared x, plus 1 sin x, plus another 1 sin x cos x, plus 2 sin x cos x, plus cos squared x. So there I'm done with my algebra. What must I now look for? And isn't sin squared x plus cos squared x equal to 1? Plus 2 sin x cos x. Therefore left hand side is equal to right hand side. Ali does identities. Step number 1, algebra. Sort your algebra. Step number 2, look for your identity. Simplify, correct your. Everything must be in terms of sin and cos. Your left hand side will equal to right hand side. How are we doing there, onliners? Talk to us. Ali does identities. Yes or no? Remember that. Don't ever forget that. Ali does identities. These are all my own methods on how I got 100% in matric. Zion like a boss. These are all my own methods that I use to remember steps and processes. I'm just sharing it with you, so hopefully you can also get 100%. Right, here we go. Right, so we done with that. Let's do another one. Watch this, very popular one. Prove that 1 over 1 plus sin x plus 1 over 1 minus sin x is equal to 2 over cos squared x. 5 marks. Left hand side, let's start. Algebra, left hand side. Where's your left hand side? That's your left hand side of your equal to sign. Right, let's start. Algebra, algebra. Put your pens down, let's do it together. LCD. Lowest common denominator is 1 plus sin x into 1 minus sin x. Yes or no? Yes. Right. 1 plus plus. 1 minus and 1 minus will cancel. What am I left with? 1 plus. 1 plus sine x times 1 is 1 plus sine x. Now collect your like terms. Minus sine x plus sine x is 0. 1 plus 1, grade 11, 1 plus 1 is how much? Oh, so clever. All over. Isn't in algebra, this is the difference of 2? 1 times 1 is? Positive times negative is? Sine x times sine x is? Right, algebra is done. What's the next step? Where's my identity? So isn't my answer 2 over, isn't this my identity? 1 minus sine squared is what? Left hand side is equal to right hand side. Ha! Let me, right now you want to title fight. You want to fight Mike Tyson now. You're ready now. You fight 2 weak opponents and you already think you're ready to fight Tyson. He's going to knock you out. You know, Alan Cool J said, Mama going to knock you out. Papa going to knock you out. Are you ready to get knocked out? Onliners, are you ready? Of course I'm going to give you another one. I'm throwing you now into the deep end, Baba. I'm now throwing you into the deep end. Yes, of course. Let's see who's sharp. One minus 2 sine squared A over 1 plus 2 sine A cos A. You need to prove. It's worth 9 marks. It's worth 9. Is equal to 1 minus 10A over 1 plus 10A. Yo, 9 marks, Baba. Here we're going to work on both sides. Left hand side completely simplified in terms of sine and cos. Right hand side completely simplified in terms of sine and cos. At the bottom, left hand side must equal to right hand side. These 2 fights. We're fighting on the left hand, we're fighting on the right. You're going to be fighting both hands, Baba. You are not punching only on the right. You're punching June, July. Chisamba. Let's see. Hey, Tyson got nothing on us, boss. I'll show you how to crack this, how to dala this thing. Come, Tyson, bring your shots. Shoot your shot. Right. I'm going to do this. I'm drawing a line down the page. Left hand side, right hand side. Let's see. Left hand side, right hand side. In this case, I'm going to start with the right here. Right hand side is 1 over 1 minus 10A is sine A over cos A. Divided by 1 over 1 plus 10A is sine A over cos A. Again, I move it to the side. Now I'm going to do algebra. Algebra, Baba. LCD. Okay, you carry on. I know where I'm going with this. Let's see if you can get it. much time we got left before break? Ah, excluding pass. We got time. I'll give you 5 minutes. If you can't do it in 5 minutes, you won't get it right. Trust me. Come guys. While you doing this, I'm taking a 5-minute bathroom break. I'll come back and I'll give you the answer. I'm drinking too much of water. I'm back in 5 minutes. Do it. Finish it. Right. Get it done. See you in 5. our onliners. Onliners, did you get it? Did you get it? Are you done? Let's go, let's go, let's go, let's go, let's go. Is the whiteboard up? There's it. Whiteboard, make it down. Make it full screen there, keep down. Let's go. No, relax, relax. This is fun. Right, let's go. Time to fight. 1 minus cos A, your common denominator is cos A. 1 into cos. 1 into cos, cos times 1 is cos A. Minus cos into cos 1 times sin A is sin A. My common denominator here is cos A. 1 into cos, cos times 1 is cos A. Plus cos A into cos A 1 times sin A is sin A. Let's sort our algebra out. Cos A minus sin A over cos A. Tip and times cos A over cos A plus sin A. Cos A and cos A cancels out. Numerator times numerator, denominator times denominator. Cos A minus sin A over cos A plus sin A. Right, that's its simplest form. Let's do this side, left hand side. The number 1 is sine squared A plus cos squared A, and then minus 2 sine. No. I'm just thinking. Wait. Yeah, but then minus 2, but then I'm going to have to get rid of it. Okay, let's leave this. 2 sine squared A. Let's leave that. Quiet all over. The 1 here is sine squared A plus cos squared A plus 2 sine A cos A. Now, I need to get rid of this cos squared A here. I'm just trying to think here. 1 minus 2 sine squared A. Okay, let's go. In my denominator, let's look at our numerator first, right? Sine squared A. The cos squared A, wait. In my numerator, I got sine squared A minus 2 sine squared A. Wait. 1 sine squared A. Watch here. 1 sine squared A minus 2 sine squared A is minus 1 sine squared A plus cos squared A right, and here my denominator, I can factorize that. I'm going to get sine A and sine A to give me sine squared A, cos A and cos A to give me that, to give me cos squared A, and that's going to be plus plus. Right, so cos A plus sine A, right, now wait. So that's going to be minus into, now I'm going to be left with sine squared A minus cos squared A all over sine A plus cos A into sine A plus cos A. Minus sine squared A minus cos squared A is a difference of 2 squares. Sine A minus cos A into sine A plus cos A all over sine A plus cos Now that and that will cancel out. Negative times negative is a positive, so here we go, cos A minus sin A. There we go, there's my right hand side. If I multiply this out here, I'm just going to do it in red because I don't have space. I'm just moving over here. Negative times positive, so I'm left with cos A minus sin A all over cos A plus sin A, cos A plus sin A, which is equal to my right hand side. There we go, we are completely done. Like a boss. The number one is sine squared A plus cos squared A. That gives me 1. Now 1 sine squared A minus 2 sine squared A is minus 1 sine squared A. Now I took out the minus, so I changed both those signs, and that's the difference of 2 squares. Then I factorize and I cancel. This one here is sine squared A plus cos squared A, and there's your 2 sine A cos A. This is as nasty as it can get, so go home, practice on it, and master it like a boss. It's 12:30 at the moment, we're going for lunch. I want to do general solution and graphs immediately after break. Let's resume at 1:15. 45 minutes. I'm giving you a 45-minute lunch.
And that was Mohammed Khota giving us, the paper 2 of Awqaf Maths Workshop live from Falaah College in KZN. And now joining me is Thandi Modise. Thandi Modise, as we know, that is a product, of these kinds of workshop. Now what we will do now is that we will be talking to Thandi, as she will be going, they will be going through with us as to how, this program has sort of helped them, into trying by all means getting whatsoever is needed, in order to go through and pass that paper. So Thandi, please welcome to Awqaf Maths Workshop. How are you doing?
I'm great. How are you? Thank you for having me.
I'm great. We've got students here who might be sitting here and asking themselves if, am I the one, to go on and master, this mathematics and so on? Because when you get a feel of all these students who have logged in, some of them are new, they need someone like you, Tandy, who's been through it all, to give them that sort of encouragement that they can go on, and pass this mathematics that they've been struggling with.
So honestly, I am not going to lie to you. When I first started the sessions, it was a bit late for me because I started it in grade 12 and I had no hope that I'm actually going to pass. Because like during the sessions in 2022, um it was really hard. It was really hard considering the fact that I never did grade 10 fully, so I did not have the foundation of everything. In grade 11 we had to go to school like maybe like 6 times or 10 times a month, considering, and mind you, there's like 20 school days. So I had no hope that I'm going to pass maths like at all. And I was like at level 2, so I had no hope at all. And one of my teachers was like, hey guys, I have a link of a certain workshop, and I would like you guys to give it a try and see if you can actually learn something from it. So when we got the link, we were not even interested at all. We were like, no, sir, we cannot do it. It's too hard for us. And actually, we are not interested at all. So he was like, if you don't do it, you're going to get a hefty punishment. And just for you guys saying that, I know you're not going to be able to do it at home. So here's the thing, you're going to come to school and we're all going to do these sessions. We're going to do these lessons together. So we went to school, and after going to school, in the first like few minutes, we were not interested. We were just reckless. We were not doing anything productive at all. And then we had to listen to Mr. Khota. And after listening to
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Waqf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments,
can you hear me now?
while
I
the
don't know
fruits
what happened.
support a wide
Yeah, I
variety
also
of
don't know what
charitable
happened,
causes.
but I'm trying to
Visit
fix that.
awqafsa.org.za to discover how your
Let's
Waqf
give it 10
can
seconds.
bless our community
and-
with a legacy of care.
Okay, now I think you can continue. Can you
I
hear
didn't
me?
hear that. Oh yes, I can hear you now.
Okay. You can continue.
So now we got to school, right? After getting to school, we were not even interested in whatever was going on because our teacher, Mr. Ngobeni, actually connected the whole thing to the smart board so we can all see. So we were not interested, we were not paying attention, we were not paying attention, and we were all on our phones. And after listening to Mr. Khota for like a few minutes, we were actually like, you know what, actually maybe we might get something out of this. And then we started listening to it. And then after that whole session, I left the classroom thinking that, you know what, I think I can take on mathematics. I think I can actually do better than I thought I would do. And then the second session, the following day on Sunday, we all came. It was like huge numbers now, and we were actually engaging with Mr. Kota and each other and our teacher as well. And then after that, on Monday, I think my teacher was actually like, you know what, guys, I want to test you to see if you actually understood something. And then he actually gave us like a past question paper. And like after calculating my marks, I would like get um, 50%, 60% of the test. But after calculating everything, after writing the test, I actually managed to get close to like 60% and 70% on the test. And that was to prove that actually I did learn something from Mr. Kota, and it was actually great. So I felt like, you know what, I'm ready for this exam. Whatever happens, happens. And then another session came. It was towards the finals. It was towards the finals. And then we did everything all over again, but then this time we were focusing on the possible questions, right? So when we were focusing on the possible questions, I actually like had a little bit of doubt, to say that, okay, these are more difficult than the ones we did. So how am I going to do this? How is this going to be? But then our teacher actually assured us that, you know what, guys, on the test, on the small test that I gave you that day, I managed to see that you can actually do better than you've always done. So right, we went through the sessions, we engaged. It was just an amazing session. And then after that, during the finals, I went into the exam scared. I was scared. I was trembling, not knowing what to expect, and it was really a scary feeling, right? But then we actually got into the exam room. We got our question papers. I prayed a little bit, Mr. Ngobeni. I prayed a little bit, right? And I was like, you know what? Whatever happens, happens. And then I actually wrote the test. I left the exam room thinking that I didn't do as much as I thought.
Tandy, we've got
I was
issues
good.
with
I
your
didn't do
sound.
as much as I.
Can you hear me? I'm suggesting, Tandy, if Mr. Clement, we also have Mr. Clement Kobeni here, who is the teacher in question actually that Tandy was talking about, that when they refused, to subscribe to the link and so on in order to get this met, what she did, what the teacher did, Mr. Clement Gobeni actually forced them to actually come to school, and do this collectively. Mr. Clement Gobeni, welcome to Awqaf SA.
Yes, yes, yes. How are you? How are you, sir?
I am doing very well. I'm quite encouraged, that there are teachers who are encouraging other students, to listen to other teachers, because you get this thing now. A teacher is all for himself, these are my students and so on. But you were quite courageous, in recommending this platform to your students.
Yes, man. Yes, I remember very well. It was, I think it was my metric, my metric 20. I think it was my metric 2022. 20, maybe, yeah, my metric 2022. Yeah, and this class. Yo, that class was what they were not listening. When you teach them maths, they were having lack of basics. It was tough for me, and I tried different strategies. My principal were on my neck, wanting result. I remember term one, it was tough because I was having plus minus 42 learners in that particular class. And my term one result were not good. I think I was ranging around 40% pass rate. So I have to come up with something. Principal said, you know what, we need result. You must come up with something. Then I went in different platforms, meeting different teachers, collaborating. Then it was not working. Then until I went to the platform. Then, man, when I check this platform, I see, man, no, man, this platform, because if it was this topic called probability, that probability, then I wanted a strategy. How can these kids improve their results? Because if I can teach, but they're not getting it, they're not passing. What is it that I must do? So I wanted to share, I wanted a strategy actually when I went to the platform. Then to check as a teacher, oh, after understanding those probabilities, because of it was this other thing of arrangement and this topic of arrangement, then it was difficult for me to make it simple for my learners. Then after that thing, then I went to then I realized that no man, even learners they can log in. If you have learners in your school, you can log in and watch with learners. Then I said no. One day I said no man, let's meet, let's all watch this platform. Learners were not, learners. They say no, why are you watching on the platform? Why are you not teaching us? Those things. I said no man, let's give this gentleman a chance. Then they teach. Then I organize, I log in with learners, everything. After the lesson, learners were happy. Then I realized, no, man, this is a strategy. But I threatened them that if you don't come and attend the class, the online class, you must know that you must come with your parents. And then I know learners, once you come with your parents, they don't want to be exposed or to be embarrassed in front of the parents. So it was my
Yes.
strategy. Then they started attending, and it was working for me. I teach them, then I pause sometimes. I pause, then I ask them questions. I record those lessons. We use different strategies. Even Tandy as an individualist was like, ah, wow, now I like math. She was like improving, improving. Yo, their result was like, wow. Then that class, all the learners were enjoying. Every time when I teach them, they said, "Manner, after we want to watch the video, then after you'll come and re-explain to us." Then it was one of my strategies. And then my results were wow. Term one, I got 40%. June exam, my results started improving. Then I managed to get, it was in that particular class, I think 92% learners pass. Learners like Tandy went to Cape Town, other learners to Durban. And what I like about that, there's this other learner who were watching as well, who used to watch the videos, and I think it was Tandy's friend or classmate. That learner now, she will be coming to my school and do teaching practice for mathematics. She's a
Hmm.
teacher. She's going to be a teacher now for mathematics. So it was like, wow, are you a teacher? You said you don't like maths. I said, no, sir, I want to be like you. So those things like, that group, Matric 2022, was my best metric ever. So even now, that's why I want this program to continue. And then even these learners that I'm having now, I'm encouraging them. We should not start in grade 12. We must start in grade 10 so that we can build the confidence with them. Then, so those are
Yes.
the things that I'm doing with these kids. Yes. So
It's
I.
very encouraging, to hear that you are encouraging the students, to start, from grade 10, so that by the time they go to grade 11, they are well accustomed, with what happens here. And this is a great platform. I know the pressure you must have been under, with the class of Tandy, them underperforming and so on, because it all goes back to the maths teacher. The parents at home, the people who are, sort of looking at the results of the school, it all goes back to the maths teacher. They don't care about the students and so on. How has this program relieved you of such pressure?
After I've after the result, especially after the matric, I was like, wow, everyone were coming to me, say, yeah, Sengolweni, thanks a lot. And I told them, it's not about me, it's you. It's the belief that you are having, the bigger picture that you are having. Because of learners like Botandi, they used to say, I want to go and study at Cape Town. Hey, Cape Town, Cape Town, and getting level 2. So it was like, wow, like the way, like after the videos, after the maths program, after the our classes that we are attending, they started to change their mindset. I used to tell them that you must have a bigger picture, you must know where you are going. So I was like, wow, even myself, when I see that Tandy now, she's in Cape Town, I used to, every time she calls me, hey sir, you said, yeah, Cape Town, I won't be in Cape Town, such things. So it was like, wow, even myself, like I was, even the principal was happy, saying, going, how do you make it? I said, no, man, it's my secret. I didn't even disclose to my principal. I said, no, it's my secret. But after my next, I remember last year, my learners in that, but the class that I was having 41 last year. Only 2 learners failed. I got 98%. So those
Hmm.
learners were failing because of they were not willing and everything. But so I see that it's working. Even now, I'm happy. That's why I'm so happy. I'm so even proud with Tandy.
Tandy, yeah, your teacher is proud of you, and I'm glad that you are now back online, because we were talking about you, yeah, that your class, before you were introduced to this platform, ish, bening alaleli.
Yeah, that's true. That's true. Actually, he had problems. We all had problems. Shem, and my class. Mm-mm. It was hectic. I am not even going to lie. It was really, 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 really bad. Yo, it was bad. But after the
You know,
program, it was like we changed our mindset and it was for the best, honestly.
we heard that you perform quite very well, in your final exam to such an extent you ended up going to Cape Town. Are you still in Cape Town now?
I am still in Cape Town and I'm studying chemical engineering. So yeah,
Hmm. So,
yeah.
how are you planning to give back, to the community? We've got a shortage, of people who love mathematics for what it is. You only have
Mhm.
people who are doing mathematics in order to pass it. But it's quite encouraging to find people, who love mathematics. They've actually made mathematics a love of their lives. So how are you planning to give back to the community as well in order to make sure that those kids, who see mathematics as an obstacle, rather see it, as a subject and they fall in love with it for what it is?
So honestly, at the moment, since I'm still studying, I was trying to share the link to everybody I know, each and every parent I know that has like a learner in grade 10, 11, or 12. But then I think as soon as I am done with my studies, I'm actually going to venture into trying to tutor other learners that were like me, that had no hope at all, so that I can actually instill some hope in them to show that, hey guys, I was once like this, and look at where I am right now. So as soon as I'm done with my studies, I think I'm going to venture into tutoring some of these learners so that they can also have hope, so that they can also do great things. So yeah.
Mr. Clement, we believe that you are on your way. Just before we let you go, there are students who are probably watching now. There's 61 on our YouTube channel. They're actually watching this now. Some of them, might not have the love for mathematics because it's all about loving the subject first, and then you go on to understand it. What would you say to them? What would be your words of encouragement to them?
I will start by saying that they must start knowing what is it that they want, what they want to see themselves in the next coming years. They must have their own a bigger picture. Like I used to say to Wotan, decide what is it that you want, what is it that you want to achieve. If you want to change the situation in your family, the only thing that will make you uh, prosper is only to focus on mathematics and physical sciences. And what they did is they work very hard. They started by setting a small goal, like saying that, you know what, next test I want to achieve a level 4. Then they move for level 5, and until they end up with level 6 or 7. So you must start by a small thing. Don't rush things. Don't start by saying, hey, I want to be a doctor. No, start with the smaller thing, and then you take it from there. And that's why I will say to the
Uh,
learners, or that's
uh,
what I watch.
uh, And Tandy, to you, as well as you have heard Mr. Clement Gobeni. And Mr. Clement Gobeni, actually Tandy is the one who introduced you to this platform, and he was pushing you guys. I know students sometimes, Mr. Clement has told us that he threatened that if you don't come, in order to join and stream the platform, he was going to call your parents. That's when you guys only obliged. Um, uh, what are your words, of thanks, to Mr. Clement for having introduced you to this platform? Because I know sometimes it's difficult for the maths teacher, that the pressure that comes, with them having to perform, because the department, the parents, whomsoever is looking at the maths teacher, not at Tandy.
So firstly, I'd like to thank you very much for Ditiro and introducing us to this project. I know it was a little bit late because I joined Ditiro at a very late time during the year, but it actually helped me. And you introducing me to the program actually helped me even more because without you and the program, I wouldn't be where I am today. if anything, I would still be trying to upgrade my math and physics marks. But then because of you actually helped me and pushed me to get to where I am today, I, I can't even, words can't even begin to describe how I feel and how thankful and grateful I am to you. And so thank you, thank you, thank you very much, and continue being the amazing teacher you are. Thank you.
And Tandi, we believe that you were with Awqaf SA, at the South Peninsula doing the grade
Mhm.
10 maths workshop. How was that?
It was actually insightful and it actually reminded me of when I was in grade 12. But then this time, like the learners had a different attitude to what our attitude was. They were more interested in learning, unlike us in the beginning. But then it was really amazing to see and to see how they were engaging with Mr. Kota, how they were managing to solve the problems and all that. It was really insightful and amazing to see. It was out of this world, honestly. And I wish I was in grade 10 with them again because I felt a little left out that I didn't bring my book or pen or pencil just to solve those equations again. But it was really amazing, honestly, and I was following along. Yeah, it was good.
Uh, Mr. Clement Gobeni mentions that he is trying by all means to introduce this platform, the Awqaf Maths Workshop, also to his grade 10 students, so that grade 10, grade 11, and by the time they reach grade 12, they are well accustomed with that. So how is that helpful, and how would you encourage, those students not to be like your class Tandy that refused, to form part of the stream, but they just go there willingly without Mr. Ngoben having to threaten them with calling their parents?
Okay, so I honestly wish we had this platform back in grade 10, but then it was really hard because, mind you, it was 2020 and it was COVID-19 lockdown, and we didn't even have like the basic foundation. We didn't know a lot of things. So, guys, I would actually like urge you to do this willingly, to do this with love, because if you don't, it's going to be hard to catch up in grade 12. See, now you have like the opportunity to get the basics you need in order to be in grade 12. I didn't do my grade 10. I did half of my grade 11, and it was really hard. I had to learn new things in grade 12. So since that you guys have the opportunity to do all these things now, I urge you to do it, guys. It's going to help you in the long run. It's going to be amazing too, because some of the students that were on this platform actually managed to get 99% and 100%. So I believe that you guys can actually do it, seeing that you have a head start in math, a head start in life. So guys, please, 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 please do it. It's going to be beneficial for you. It's not a waste of time. It never will be a waste of time. Just do it, guys. And it's going to be beneficial for you and your career in the future.
We say thank you very much to Tandi Modise, a former student, a former grade 12 learner. She's currently doing her, course, in
Chemical
Cape Town here
engineering.
now. Tandi will be joining us, in August, at the South Peninsula, and we look forward to meeting her, because she is part of those people, who are ambassadors of this platform that we have here, of this initiative, because we can say that this is what we have done for 9 years, and these are the people that we have produced, Mr. Clement Gobeni, the teacher of Tandi, told us that, when he came across, this platform, he was under immense pressure because his students were not performing. And everyone, the department, the moderators, they are looking at him as a maths teacher. So when he came up with this idea, it was one of those solutions, to his program, to such an extent now that Mr. Klibet Ngowen is saying that the pressure he had, at that time in 2022 is no longer there, because he has started to introduce even his grade 10 students, grade 11, and grade 12 to this platform, to make sure that By the time they go from grade 10, up until grade 12, they are well accustomed with this initiative of Awqaf. We thank you very much, Thandi, and I think now it's time to let you go. I can't believe it's been 30 minutes since we've been talking here. I'm enjoying myself.
Yeah, I'm also enjoying myself. And thank you so much for having me. And please say hi to Mr. Kota and Mr. Abdullah for me.
I will make sure that I do pass your highs to Mr. Kota and Mr. Abdullah, and that was Tandemodise. We will be back at 1:30, and Mr. Kota will be resuming at 1:30. Now we take our short break. Till then, see you. Everything is good in Cape Town, Mr. Khota.
Here we go. Here we go. Let's go. Right. Last round. Last round. General solution. Let's go. Let's go. Let's go. Let's go. Let's go. Make the screen big. Take down. Enlarge the screen for us. Let's clear this. We're starting with general solution. Pay attention. And like I gave you acronyms in each one, I'm going to give you an acronym to sort general solution as well. Here goes. General solution. Now, general solution. Listen. For sine, it's your answer plus k times 360, where k is an element of integers. I'll explain to you what this means. You just need to learn this. Right. Now remember, all, if it's positive, you have to give 2. 180 minus your answer plus k times 360, where k is an element of integers. That's for sine. For cos, you say plus minus your answer, plus minus, because it's y, quadrant 1, quadrant 4, plus minus, plus k times 360 or 360k, where k is an element of integers, that's a z integers, or for tan, you know, remember your sine graph makes its appearance every 360 degrees. Your cos graph makes its appearance every 360 degrees. Your tan graph makes its appearance every 180 degrees. That's 360, 360, 360. It's your answer plus k times 180, where k is an element of integers. So you just remember for sine and cos it's plus k times 360. For tan it's plus k times 180, where k is an element of integers. Now I'll show you the art of doing it. Onliners, are we fresh? Are you ready? They say they can't hear. Some of you can't hear. Let's see. Maybe you can try just disconnecting and reconnecting. But I think we've got full sound. We're moving on full sound here? We're moving on full sound, guys. We are moving on full sound. We are boosting all engines in full capacity. Right, here goes. You've taken this down. Okay. Now if the question says give the general solution, we're not saying solve for x. We are just saying give the general solution. Pay attention. Pay attention. So let's say the question says give the general solution. The question wants the general solution. Why? So now they tell you sine x plus sine squared x is equal to 0 for 4 marks. Give the general solution. Take this one down. I'm going to show you different slides. Then we're going to do solving for x. This is just general solution. Onliners, are we ready? Are we activated? They can hear now. Lovely, Zodwa. You couldn't hear Mr. Sipo. Okay. Sipo, sorry. Right, here goes. Here goes. Because it's a square, you have to give 2 solutions. Quiet. So we take out the highest common factor, HCF. Sin x into 1 plus sin x equals 0. Factorize. Now give your 2 general solutions. Sin x is equal to 0 or 1 plus sin x is equal to 0. X is equal to shift sine 0 is 0 degrees plus k times 360, where k is an element of integers, or x is equal to 180 plus k times 360, where k is an element of integers. On this side, sine x is equal to minus 1. So x will equal to shift sign minus 1, shift sign minus 1, minus 90, plus, for sine, k times 360, where k is an element of integers. And there we go. That's your answer. You get 4 to 5 marks just for that. This is example number 1. We're going to do about 3 or 4 examples of this before I actually show you how to solve for x using general solution. This is just a general solution. Learn. Onliners, we all okay? Chuma, you are ready. Asipe, you are ready. Job, you can hear, you are ready. Maniaco, Trifina, you are ready. Praise, how's it, my man? Praise, he's our man. He can do it, no one can. Go, Praise.
Hello, I'm back.
Here we go. Arsenal still. Welcome. So you've got this one down. Those of you who have taken that one down, let's do another one. Right, watch this. Give the general solution of sin x minus cos x equal to 0 for 4 marks. Right, let's do number 2. This is example number 2. Example number 2. All we do, we take the minus cos x on the other side. So we say sin x is equal to cos x. Now we divide both sides by cos x. So we divide by cos x. We divide by cos x. That and that will give me 1. What is sine over cos? Tan x is equal to 1. X is equal to shift tan 1, 45 degrees, plus k times for tan, 180, where k is an element of integers. Final answer. Learn. Right. Now I'm going to show you where they want you to find the 2 points of intersection of 2 graphs. So maybe they give you a sine 2x graph and they give you a cos x minus 45. Now obviously you're going to equate the 2 and give the general solution. Right. I'm going to show you that. So I'm building you up. You're going to learn. Okay. Okay, before we do that one, let's try, let's come up with one very popular one. Can I clear the frame here? You good? Onliners, you good? Watch this one. Give the general solution for 6 months. Answer, let's do it together. Wait, I forgot something. Right, here we go. This is a trinomial. The first one is squared, the second one is squared. The middle term is multiplied. So here we go. Watch. Sin x times sin x. Cos x times cos x. Give me cos squared x. Now, my factors of 3 to give me a 1. It must be a 2, isn't it? Because 3 and 1 will give me a 2. Sorry, make it a 2. Put a 2 there. Put a 2. So that's going to be 3 and that's going to be 1. make this a 2. Make that a 2. There we go, make that a 2. So we got 3 and 1 to give me a 2, that will be minus, that will be plus. Now we got 2 factors equal to 0. So sine x plus cos x equals 0. Or sine x minus 3 cos x equal to 0. Sine x is equal to minus cos x. Divide by cos, divide by cos. So sine x over cos x is equal to minus 1. Tan x is equal to minus 1. X is equal to shift tan minus 1 is minus 45 plus k times 180, where k is an element of integers. Or on this side, sine x is equal to 3 cos x. Divide by cos x, divide by cos x. Sine over cos is tan x is equal to 3. X is equal to shift tan 3. What's it? 71,70. Shift tan 3, 71,56. Plus k times 180, where k is an element of integers. Learn this also. It's a template. All these are different templates, all different styles. If you master this, hopefully there's nothing in the exam that can beat you. Okay. Here we go.
Bismillah.
Bismillah. Bismillah. There we go. Yo, we are on fire, bro. We are on fire. Now I'm going to show you how to solve for x. One is giving the general solution, the other one is solving for x. Now pay attention. In fact, before we do that one, I was going to show you the points of intersection of the two graphs. Watch that. Check this one out. Let's say they told you f of x is equal to sine 2x and g of x is equal to cos x minus 45. Now they say give the general solution. Find the points of intersection of these two graphs. Give the general solution of where these two graphs are equal, where f of x is equal to g of x. For 6 marks. Pay attention, it's a template. Something you've got to learn. You need to know how to do it. Watch. Show you some mathematics here. Here we go. Learn this. Okay, so we now know that f of x sine 2x is equal to cos x minus 45. Pay attention. You can't divide by cos and divide by cos because your two angles are different. So you change the sine to cos. You change the cos to sine. Change the cos to sine. Change the cos to sine. Watch here how we do it. So sine 2x is equal to sine 90 minus x minus 45. Because sine 90 will change the name to cos x minus 45. Are you all with me? Now watch. Now watch. Pay attention. Onliners, learn. From there we go to here. From there we go to here. Now watch. You cancel and you cancel. So watch here. 2x is equal to 90 minus x minus 45 plus k times 360, where k is an element of integers, or 2x, this is quadrant number 1. Remember, for quadrant number 2, 2x is equal to 1. Remember, quadrant 2 is 180 minus. So 180 minus 90 minus x minus 45 plus k times 360, where k is an element of integers. That's the trick. That 180 minus where k is an element of integers. So 2x plus x is 3x is equal to 90 plus 45 is 135 plus k times 360, where k is an element of integers. X is equal to 135 divided by 3 is 45 degrees. 135 divided by 3 is 45 degrees plus k times 360 divided by 3 is 120, where k is an element of integers. That's your first general solution. Or 2x is equal to 180 minus 90 minus x plus 45 plus k times 360. So 2x is equal to 180 minus, minus into 90 plus 45. Let us go. It's 180 minus 90 plus 45 is 135 minus x plus k times 360. Let's solve for x. We're solving for x. 2x is equal to 180 minus 135 plus x plus k times 360. We're not yet done. Let's solve for x. 2x minus 1x is x. 180 minus 45 is 45 degrees plus k times 360. Where k is an element of integers. There we go. There's your two solutions. 3 marks on the top, 3 marks at the bottom, 6 marks for this question. Learn. Quadrant 1, that's your one answer. Quadrant 2, that's your second answer. Huh? No, not divide by 2. The plus x came on that side as minus x. So 2x minus 1x is 1x. Not divide by 2. Well, what? Yeah, what? Alright, here we go. We go. Learn this. Learn from now to grade 12. Okay, now to solve for x. Using your quadrants. Alright guys, I hope you're taking down these templates and learn them. General solution. Lady Brandt, Adrian Kutzer, Lady Brandt, you know where is Lady Brandt? Isn't Lady Brandt there on the border of Lesotho? Somewhere there. Somewhere far in the Free State. Deep in the Free State. Let's go. Beautiful to see the amount of reach we're getting, guys. Learn. Okay, now what's this general solution here? Clearly, I hope you've taken this down. Come guys. Let's go. I hope you took it down. Remember, this is also streamed and saved on Awqaf SA YouTube. So you can re-watch these 2 days over and over until you understand it properly. So it's recorded. These sessions are recorded on the Awqaf SA YouTube page. Here goes. I'm clearing the frame. I hope you took it down. For those of you who didn't take it down, just take your phone. Take a shot. And let's go. Right, here goes. Now they give you, check this one out. Check this. Right, we want solve for x. Solve for x. And they tell you sine 2x plus 15 degrees I make that 3 minus 1 equals 0 and x to plus 360 for 7 marks. Right. When we do something like this, here's the acronym, here's the process on the side. SSGR. Right, I'll tell you what it means. You can make up something stupid. Stupid students get rabies. I don't know. Stupid students get rabies. I don't know. Make up something. The first S is standard form and Sokatoa. The second S is your shift key on your calculator. Actually, you don't even need to put Sokatoa here. You can just use standard form. S for standard form. S for shift, use the shift key to look for your angle. G, attempt your general solution. And R, look at your restriction and solve. So SSGR, this is the process. That's the process of solving for X. Now it's going to be quite a bit, so you need to follow. Right, let's do standard form. So standard form would be in our answer, sine 2x plus 15 is equal to take the 1 over and divide by 3. That's standard form. Your right hand side must be a fraction. So this is the first S, standard form. Now we use the shift key on our calculator. So we're done with that. Let's go. Shift sine 1 over 3. Shift sine 1 over 3. 19,47. Now pay attention. Watch here. Watch here. That is what we call reference angle. So we say reference angle is equal to shift sine 1 over 3, 19,47. Let's call it 19,5 plus k times 360, where k is an element of integers. This is quadrant number 1. It's sine. So now I say quadrant number 2. Or reference angle is equal to 180 minus 19,5 plus k times 360, where k is an element of integers. We are far from finished. We attached our general solution. So standard form, shift, general solution. Now the last part, restriction and solve. Pay attention, put your pens down. Learn this one as a template. Learn this one as a template. You'll be able to get them all right. We'll do another one after this. Follow. What's your reference angle? 2x plus 15 is equal to 19,5 plus k times 360, where k is an element of integers. Now solve for x. 2x is equal to 19,5 minus 15, 4,5 plus k times 360, where k is an element of integers. X is equal to 4,5 divided by 2 is 2,25 plus k times 180, because we divided it by 2, where k is an element of integers. Or reference angle 2x plus 15. 180 minus 19,5. 160,5. Follow. So 2x is equal to 160,5 minus 15. 145,5. I took the the 15 over. Now solve for x. 145,5 divided by 2. 72,75 plus k times 180, where k is an element of integers. This is just our general solution. We now need to find all the answers between 360 minus 360 to plus 360. So all you're going to do now, for solution 1, you're going to put, I just want to show you. So x equal 2,25 plus k times 180, right? So here, solutions. Right, 2,25, so you're going to say x is equal to 2,25 plus k times 180, so it's plus 0 times 180, plus 1 times 180, plus 2 times 180, minus 1 times 180, minus 2 times 180. Now, which of these fall within your restriction? Or x will equal to solution number 2. This is solution 1. Wait, you will answer in the exam exactly like we do this here. Solution number 2. It's a bit long, but it's easy. What was solution number 2? Let's go back. 72,75 plus k times 180. 72,75 plus 0 times 180 plus 1 times 180 plus 2 times 180 minus 1 times 180 minus 2 times 180. Now, which of these solutions fall within your restriction? That's what you are about to find out. Let's go. 2,25 plus 0 times 180, you're going to get 2,25. 180 plus 2, you're going to get 182,25. 362. Wait, 362. We're already out. 362,25. So that one's in, that one's in, that one's out. And mine, okay, now wait. Minus 180. Minus 180 plus 2,25. That one will be in. Minus 177,75. That's in because it falls within our restriction. Minus 360 to plus 360. And then minus 360 plus 2,25, we get minus 357,75. That one's in. So we got 4 solutions there. 1, 2, 3, 4. Let's go here. 72,75. That's 72,75. That's in. 180 plus 72 is 152, isn't it? 152,75. That's in. 360 plus, that's out. Minus 180 plus 72,75. Minus 107,25. And the last one, minus 360 plus 72,75. Minus 390, whoa, no man, minus 360 plus 72,75. Minus 287,25. And that's it. So how many solutions do I have? 1, 2, 3, 4, 5, 6, 7, 8. You have to write out all your 8 solutions here. 2,25, 182,25, minus 177,75, minus 357,75, 72,75, 152,75, minus 107,25, and minus 287,25. And there we go. That's how we answer SSGR. It becomes long because there's so much. 2,25 plus k times 180, so it's all your integers. 2,25012 minus 1 minus 2. And your second solution was 72,75 plus k times 180. There we go. And we're putting in all our integers for k. Here we go. 0, 1, 2 minus 1 minus 2. 252. Okay. 250. All right. 252. Sorry. Right, here we go. These are yours. Let's do another one, but I'm not going to do it so long. We'll give it to you one. Let's give you one in terms of 10. Let's give you one in terms of 10. Let's give you one in terms of 10. Here we go. SSGR. Standard form, shift key, general solution. Where's your G? There's your G. SSG. G. We split it up into 2 because it was quadrant 1, quadrant 2, and solve. SSGR. And now, when you only do this if they give you a restriction. If they give restriction. Like this, they gave you a restriction. Then you do that and that. If they don't, you just leave it on the previous page. You don't do all of this. Alright? Okay. Onliners, how are we doing? Onliners, how are we doing? 0, 1, 2, minus 1, minus 2. There we go, there we go, there we go. Right, let's go. Let's go, let's go, let's go, let's go. Let's get the frame. Okay, let's do another one in terms of 10. Give the general solution. Let's make this 2 10 half x. Let's make this interesting. Right, they give you this. Question, answer. Let's go. No restriction given, so we don't need to multiply our integers in. Right. SSGR. SSGR. Let's go. Standard form. Okay, I'm going to move a little fast, so follow me. Quiet. Put your pens down. Let's do the first as standard form. 10 half x plus 10 is equal to 8 over 2. So 10 half x plus 10 is equal to 4. Now here you don't need to split it up. Here in fact you can go shift tan 4, reference angle. So reference angle is equal to shift tan 4. What shift tan 4? 75,96. Check. Shift tan 4 plus k times 180, where k is an element of integers. Wait. Now what's your reference angle? Half x plus 10 is equal to 75,96 plus k times 180. Let's solve for x. Half x is equal to 75,96 minus 10, 65,96 plus k times 180, where k is an element of integers. Now I don't want half x, I want x, so times it. Now we multiply everything by 2. So times it by 2 131,92. 131,92 plus k times 180 times 2 is 360. Be careful, don't forget to multiply. And there's your final answer. You get 5 marks for that. Okay, next general solution. That is, do you want to do one in terms of cost? No, you know what to do? Yes. Let's do one in terms of cost. Come on. Come on. Come on. There's one in terms of cost. There's one in terms of cost. This is the last one, guys. This is the last one. This is the last one. Right, here we go, here we go, here we go. Guys, I'm still on line here. That's the last one I want you to do. Start with it, and then we go into our favorite topic. Oh wait, there was a question from one of the learners during break about functions, about ways f of x divided by g of x. Right, I'll show you that before we start with Euclidean. How's our time? We good. Go for it, finish this one up, 4 marks. It's marks for Mahala. I told you for cos you put plus minus. It's 3 marks. Shift cos minus 0,1625. Shift cos minus 0,1625. 99,35. So we say plus minus 99,35 plus k times 360. So x is equal to, divide that by 2. 49,67, 49,7, plus minus 49,7 plus k times 180, where k is an element of integers. That's your final answer. No restriction is given. No restriction is given, so you don't need to go and substitute your integers. We good? Right. Question. Right, there was a question, where is f of x divided by g of x? Just pay attention, let me show you how to do that one. There's a trick, there's a technique to do it. Pay attention. Very important, you're going to see that in finals and next year. Onliners, how are we doing? Plus minus, job, plus minus. Cos is always plus minus because cos occurs in the first quadrant, which is plus, and fourth quadrant, 0 minus. Cos is in your fourth quadrant, that's why we say plus minus all the time. Hope that answers your question. Joe E. Jr. Right, here we go. Quiet. Now let's say, watch here. I just want to go back to a concept quickly, right? Pay attention. Now we knew this was minus 2, that was 4, that was minus 8, this point here was 1 and minus 9. We knew that, right, where is f of x? You can say times g of x greater than 0, or they can tell you where is f of x divided by g of x greater than 0. It's the same thing. You do the same process for both of these questions. Pay attention. same thing. Where is graph F? Right, wait, before we do that. What will give you a positive result? Shh, listen. It's important, you need to understand this. Quiet. What will give you a positive answer? A negative times a negative is a positive. That's solution 1. Or solution 2. A positive times a positive will also equal to a positive. Yes or no? Yes. Right, let's do solution 1. This is how you answer it in the exam. Solution 1. Right. Where is F negative and G negative? Right. Pay attention. Where is F negative? Right. Where is graph F? That's graph F, that's graph G. Where is F negative? Where is it below your x-axis? F is negative there, between -2 and 4. So this is what we do. We say -2, right up to 4 is where F is negative. Now if there's an equal to sign, you have to color it in. But there's no equal to sign here. Right. This is where F is negative. Where is G negative? Where is G negative? G is below your x-axis for all your x values less than 4. Going to negative infinity. Right, pay attention. This is where graph G is negative. Now multiplication or division means where do the two overlap? Pay attention. They don't overlap here, they overlap there. These two inequalities overlap there. So your first answer, x less than 4 but greater than -2. That's solution number 1. Now let's go into solution number 2. Pay attention. So we're going to do the same thing. Where is F positive? Now F is positive, graph F is positive for all your x values greater than 4. Or for all your x values less than -2. That's where F is positive. Now where is G positive? Where is G positive? G is above your x-axis only for all your x values greater than 4. Where do these two systems overlap? They only overlap there. So your next solution is all your values to the right of 4, x greater than 4. That's your first answer, that's your second answer. Take this down, learn it. This is the way you answer this question in your exam.
Khota Obal, how are you doing?
Yeah, boy.
You forgot about Drake.
Please learn. I beg you, learn. You're going to use it till grade 12. You're going to use it till grade 12. Right. Now, all right, relax, Pilani. Euclidean is coming now. Yo! It's coming.
Well done, Mr. Khota. We've definitely been vibing today with the informative session. That's of the online audience. I think we are smelling some brains or cheese toast. There's something burning.
I'm telling you, it's on fire here, bruh. It's on fire. Brains are burning. Their brains are smelling like bright smoke. Right, let's go. Assalamualaikum, all good from Cape Town, sound, picture, comments, fire, vibe.
Yes, more fire. It's definitely, the session has been lit.
Here we go. Right, Euclidean. Now listen. Euclidean is very easy. Quiet. You got to know your form. You got to know. Right. Let's quickly go through our theorems that you need to know. Right. The first theorem that you need to know. The first theorem that you need to know for grade 11. Cyclic quadrilateral. We know that the exterior angle of a cyclic quad is equal to the interior opposite. So that is equal to that. I'm not giving it to you in order. I'm just giving you all the stuff you need to know. Right. Why? The next one that we need to know is that we all know that the opposite angles of a cyclic quad are supplementary. They add up to 180 degrees. Right, so your opposite angles of a cyclic quad is equal to or add up to 180 degrees. Supplementary. You're going to know this by heart. You're going to be able to picture, and when I give you the examples, you need to apply. Yes. The next one that we need to know is that quiet equal chords subtend equal angles at the circumference. Equal chords subtend equal angles at circumference. Right, so you know that. Can I move on? Number 4. The next one that we need to know is the bow tie. Okay, which theorem is this? Angles in the same segment. Angles in the same segment and circumference are equal. Right, next one. Next one. Right. Quiet. Now, when you have a bow tie from the center of a circle like this, with 3 points touch, angle at center is 2 times angle at kids and them, they are on another level here, brother. Angle at center is equal to 2 times angle at circumference. Ooh. Asamin, are you listening to this, bruh? These guys
Khota, do you need help, bruh? What did our people have for lunch?
The next one. Right. We also know when you have the spear head, like Shaka Zulu spear, you see. There's Shaka Zulu spear head.
Bible.
Exterior angle at center. Exterior angle at center equals 2 times angle at circumference. And or it can also look like this. Wait, I'll show you now. So it's like that. Or if you have your quadrilateral starting from your center, exterior angle at center is 2 times angle at circumference. So it's that one or that shape. Yes. Right, now next one. Next one. Line drawn from center of circle. two tangents meeting at a common point outside the circle are equal in length to the circumference. Two tangents meeting externally. Blah, 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 blah. Right. Now let me give you this. Let me give you the secret of this. The secret of geometry is to start, remember, parallel lines, FUN, corresponding alternate co-interior. The minute they give you radii, isosceles triangles. Triangles, sum of angles of a triangle, or exterior angle of a triangle is equal to the sum of the interior opposite. You got to know that. Right. You ready? Okay, they're ready. That's the name? Right. Here we go. Here we go. Here we go. Here we go. Here we go.
Just shout if you need help, Khota.
I'm good. Right. I'm now going to take out all my past paper here. Let's go. Usa. Right, let's start with this one here. Okay. Take this diagram down with me. Let's go. From a past paper. There we go. There's your diagram. Okay. O is the center of the circle. They give you two. So they give you from there to there. Quiet, quiet. Take it down, take it down. You better take it down with me. From there to there. From here going up to there. From here coming down to there. From here, there. This one was up until there. Okay, from there to there. Okay, that's a tangent, right? It touches at one point there, it touches here. Yeah, and that's your diagram. Nothing else. They give you this angle is 42,83. From there to there is 42,83 degrees. That's 0, that's 90 degrees. That's R, that's 15. That's T, that's 9 centimeters, and that is S. And this is point B. Right, quiet, let's go. O is the center of the circle. N is the point. ON is perpendicular to PR. This is N. This point here is N. PS and RS. PS and RS are tangents. They are tangents. PS and RS. RS is 15. TS is 9. Now wait. T is this point here. T is that point there. T is that point. So TS is 9. TS is equal to 9. Right. Question number 1. They want the size of NOR. The size of NOR. And the second question, the length of the radius of the circle. So NOR. Right, here we go. The side of angle NOR. So let's answer this. Right Now, watch here. I'm not working through a memo. I'm doing it as if I'm doing it with you in the exam. Pay attention. We know that a radius is 90 degrees to a tangent. So OR is perpendicular to RS because a radius is 90 degrees to a tangent. Yes or no? Yes. Therefore, triangle ORS is a 90-degree triangle. Therefore, triangle ORS is a right-angled triangle or a 90-degree triangle. Pay attention. So if this is a right-angled triangle and that's the angle that I want, I can use sine of theta. No, that's the whole side. I don't have it. Oh, and I don't have this side too. Ooh. I can't say 15 over 9 because I don't have this one. That's okay, that's 90. That's 90. I don't have this side. This side is 15. That side is 15. Wait. That's 15, that's 15. There's some work to be done here. There is some work to be done here. Alright, no, I didn't see that. Okay, I didn't see that one coming. Right, watch here. Okay, let's go again. The answer to question number 1. RS is equal to PS. Why RS is equal to PS, which is equal to 15. Two tangents meeting at a common point. Two tangents meeting at a common point. Right. Pay attention. Pay attention. Now there are many ways of doing it because now we've proved that this is an isosceles triangle. That will be 42,83. I can, let's do that. So therefore, triangle PSR is isosceles. Therefore, let's call that angle R1 and angle R2. Therefore, angle R2 is 42,83. Therefore, angle R2 is equal to 42,83. The angles opposite the equal sides of an isosceles triangle. The angles opposite the equal sides. Now we know that this is 90. I need to get to that angle theta, so I need to find R1. So we know that angle R1 plus angle R2 is equal to 90 because a radius is 90 degrees to a tangent. Radius 90 degrees to a tangent. Therefore, angle R1 plus R2, we got 42,83 is equal to 90. So angle R1, 90 minus 42,83. Let's go to our calculators. 90 minus 42,83, 47,17. So this angle R1 is 47,17. Now this angle is 90. Now we go in triangle ONR. Right, angle theta. That's the angle that we're looking for. That's angle theta. Is equal to 180 minus 90 plus 47,17. So angle theta is equal to and you must put the reason, sum of angles of a triangle. Sum of angles of a triangle equal to 180. So 180 minus open brackets 90 plus 47,17, and that's going to give me 42,83. 42,83 degrees. So theta is also equal to 42,83. Doesn't look like a circle, but a circle can be drawn around it because now the angles in the same segment are equal. It just means that, but it's not like we're going to use it. Right, let's answer the next question. Quiet, quiet, let's answer the next question. Find the length of the radius. They want the length of the side. That's a radius. That's a radius. Find the length of the side. Quiet, 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 quiet. So we got that as 42,83. Let's find the length of the radius. Now I promise you I've never done this question before. As I was coming here in the morning in the car, I was just going to pass papers. I said, all right, we'll do this one. So I don't have a memo. We're working through this with no memo. But we know our answers are right. Right, let's see. Let's try and crack this one together. We need to find the length of the radius. We need to find the length of the radius. Let's see what we have here. Come. I'm doing it with you as if I'm sitting in the final exam with you. So we're answering question number 2. Let's see what we have. We got 15, we got that. I can find that. If I find that, I find that. If I find that, I got the end. Ah, boom, I know where to go. Right, let's do it together. Quiet. I'm now looking at triangle PN. I don't even want to write it. PSN rather. Let's look at triangle PSN. Right, let me highlight this. I'm talking about this triangle here. So we want to find PN. Right, because we know PN is equal to NR because line drawn from center meets it at 90 degrees. Right, pay attention. Pay attention. Let's do it in triangle PSN. Now I want to find PN. So PS squared, I'm using Pythagoras. And please, onliners, don't ask me why I'm squaring and using Hyperbola. PS squared is equal to PN squared plus NS squared. Pay attention. PS squared, 15 squared. PN squared, we don't have. Plus NS squared, 9 squared. Sum of angles of a triangle. Quiet. So angle S2 is equal to 180 minus 90 plus 42,83 equals 47,17. Right, so S2 is equal to 47,17. Now I'm going to use trigonometry here to find OR. So I'm going to say tan of 47,17 is equal to opposite over adjacent, which is 47, no, which is equal to OR, which is equal to OR by radius. That's what I want to find, OR by radius over RS over 15. That's my radius over RS. So I want OR, I want the radius. So OR is equal times 15 times 15. So OR is 15, 10, 47,17. OR, my radius, here's my answer coming up. 15, 10, 47,17. 16,18 or 16,2 units. Whew, that was stressful. That was a bit stressful. And I tried it first time with no memo with it. Let's go to the next one. Ooh, this one got problems. This math is giving me stress. These are all examples. No memo, no memo. I'm taking straight. Past paper, boom. We are cracking it now. No memo. No memo. Well done, well done, well done, well done. Yes. Here we go, here we go, here we go, here we go. Next one is rough. It's a trap, Mr. K. Don't do it. Don't do it. It's a trap. Drink milk and be strong. Let's go. The next one, don't do it. Hey. Maramets. Take this one down. Let's see the diagram. Ooh, Here we go. So it's from there, going up there. Quiet, quiet, quiet. Take this one down. From there, going there. Mr. Ketri, maths is stressful, bruh. It's only when you have to get the answer in front of everybody once cut when you're not working on the level. I put myself in this. I'm a sucker for torture, you know. I'm a sucker for punishment. Right, here we go. Take this diagram down. P-O-N, P. I swear, you guys think I'm lying. There's the question. And number 4, show that NT is a tangent to the circle at N. Show that NT is a tangent to the circle at N. Ha, Musa. Let's go. Oh, and I forgot to prove that NTRO. There's 5 questions. I forgot number 3. Wait. 3, 4, 5. Wait. Question number 3. Prove that NTRO is cyclic. Prove that NTRO is cyclic. You got to prove that's number 3. That's number 4. That's number 5. 5 questions, probably about 20 marks on this. Ooh, here we go. Right, take it down. Let's go. Zianda is correctly. Yeah, the shape itself is giving us stress. Don't worry. I will not stress. Don't fear. Kaylee is here. I'm here. Let's go. Quiet. What's our time? Yo, we got 5 minutes. 5 minutes. Right, prove that TO is quiet. Come on, guys. Guys, in 5 minutes, let's crack all of this, please. Prove that TO is parallel to RP. TO parallel to RP. So we need to prove that these 2 lines are parallel. Right. Okay, let's see. Game over. Right. We know that the diameter subtends at 90 degrees and the circumference. So obviously this must be 90 degrees. If that is 90 degrees and that is 90 degrees, these 2 lines are parallel, co-interior angles. Right, so angle R1 plus angle R2 equal 90. Angle in semicircle. Come guys, work with me. Please keep quiet so that I can finish this whole thing in 5 minutes for you. Aikido. R1 plus R2 is 90 angle in the semicircle. Therefore, TO is parallel to RP. Co-interior angles are supplementary. Quiet. So we done with that. If angle TRN equals X, name 2 other angles equal to X. So tan chord, angle P is equal to X. Right, wait. Angle N or OPR equals X. Tan chord. And angle O3 is equal to X corresponding. Number 3, done. Prove that NTRO is plus x plus angle M is equal to 180. Sum of angles of a triangle. So, x plus x, 2x plus 90 plus M equals 180. 2x plus M equals 180 minus 90 is 90. M is equal to 90 minus 2x. Done. Show that NT is a tangent to the circle at N. To the circle at N. Show that NT. So now I'm going to remove this blue circle here. Why? We're on the last one. We are the last one. We got a minute to go. I know your time is almost up. Right. I need to prove that angle N, prove that NT is a tangent to the circle at N. NT is a tangent to the circle at point N. So I need to prove that this is equal to X. Can I prove that N2 is equal to X? If this is equal to X and that day is equal to X, therefore tan chord theorem. Can we prove that angle N2 equals X? Show that NT is a tangent. NT is a tangent to the circle at N. So I need to prove that N2 equals X. Oh yes! Remember there was a circle here? Wait. So that is equal to X, that is equal to X. I need to prove that N2 is equal to X. We need to prove that angle N2 is equal to X. Now you see pressure now. Pressure. We need to prove that N2 is equal to X. We got two parallel lines, right? We got that is parallel to that, but it's not parallel to this. This whole angle is 90. That angle is 90. That angle is 90. Come on, I'm not seeing it. Under pressure, I'm not seeing. 90 minus 2x. That's 90. I can get N1. What is N3? Come on. Something I'm not seeing. Wait. I know you guys in a rush. I know you want to go. Just give us a couple of minutes. Come on, let's work this one out together. 90, M2 to equal to X. That's X.
Could we observe silence, please? Could we observe silence, please? Your cooperation is needed. Thank you so much.
Prove that N2 equals X. Come on, something I'm not seeing here, man. Whoa, okay. We proved that this here was cyclic, right? Wait. All right, let's do it this way. We know that OP equals OR. OP is equal to OR, right? Because these two are radii. So if this is x, that is x. Right. Then this angle here is 90 minus x. This angle here is 90 minus x. This side is equal to that side. So this angle here is also, remember, this side is equal to that side, is equal to that side. That's x, that's x. That's 90 minus x, and 1 is 90 minus x. Do I have T2? Minus x.
Okay, that's concluding remarks there from Mr. Khota. It was really a good session. I am going to put Mr. Khota on mute because I cannot compete with the audio levels over there. So, Mr. Khota, you can stay on with me there, but I'm going to have to just mute you to keep you on there. It was indeed a very explosive session with Mr. Khota. He had an amazing cohort of learners there. We had about 400 learners. It was an absolute amazing session. 400 learners, very academically astute. They were with us all the way, and they could also point out maybe some of the shortcomings or perhaps a decimal that was out of place. That's how committed they were. So I would love to thank the Almighty, Jazakallah. We have to give all praises to the Almighty um, for granting us this opportunity to assist our learners in preparation for the June examination. To our online audience, you've been absolutely amazing. Mr. Khota, show a heart there for our in-person cohort of learners there. There we go. One love, big up. And also would like to thank our partners, Mr. Khota, namely the Department of Basic Education, iSkill, and more importantly, the Falaah School with Mr. Singh, Mr. Zafar Ahmed, and his whole staff and team that took quite a few months to prepare this, to get this cohort of learners in and coordinating things in a very good fashion. We'd also like to extend a warm gratitude to our AV service provider, Cathay Sound. If you need a professional AV technician company, then Mr. Khota gives it a thumbs up there. Mr. Cathay Sound for his professional service. He's been assisting us for many years now with this. We'd also like to thank some of our in-studio hosts, and that is in the form of Khalid Romano. What you say, Mr. Khota? Give us a big heart there if you enjoyed your session with Khalid Romano today. Yeah, he was absolutely solid. And would like to thank Tani Mudise, past grade 12 learner. She joined us today during our lunch break. She performed quite well, and she's an ambassador for the program. And also, we had her teacher, grade 12 maths teacher, Mr. Clement from Pretoria, that joined us on the session. So we'll continue to have the sessions. Remember that all of these videos are hosted on Awqaf's YouTube platform, so you can refer back to it, and you can log on to the Awqaf website for that. So that's it from myself and Mr. Khota. We bid you farewell until the next time, Mr. Khota. Over and out. That's the end of a very successful cohort of the May session. There. I have unmuted you, Mr. Khota. Final remarks before we end the session.
The atmosphere here in KZN is absolutely electric, and lots of appreciation and love for the program. Jazakallah to Awqaf. Thanks Hassanin for being our stalwart there from Cape Town, as well as Khalid. You guys have been amazing throughout the program. This program couldn't have been done without Mr. Catherine and myself, and without our IT guys at iSkill, Hassanin and Khalid from Cape Town and from Awqaf. Absolutely mind-blowing workshop, and Jazakallah for our entire online cohort. You guys have been just as exciting and loud as our in-person learners. Guys, thank you so much. Let's thank you everyone. Assalamu alaikum, good afternoon, goeiedag, and tot ziens. Assalamu alaikum, open out.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Waqf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Waqf can bless our